I feel much more at ease. So the thing I would say to my past self is, be teachable. Things will always change. And if you've got that open mindset, it'll really help you deal with the challenging situations. And related to that is seeking counsel. You can learn from others. It's okay to say, I don't know. It's okay to say, I don't understand. And that's something that I was probably fiercely independent of when I first started out. And speaking with my own team and trying to get advice on this talk, that was one of the things that they said, that they found that asking for advice was super helpful to move forward. And I think there's 2 points to that. One is, you also don't want to be that guy who's constantly asking for help and nagging everyone around them and distracting everyone around them. So take your time, go off, do some research, do some Googling, get a better understanding. And if you come to someone more senior and say something like, hey, I've got to this point, I've tried this, I've learned this, but I'm really stuck on that, can you help me? You'll find them to be a lot more receptive. One final point on this is that young children, as a sign of their intelligence, the ones who are more intelligent tend to be asking lots and lots of questions. If anyone's been around toddlers, they will know how many times they say what or why and things like that. Somewhere along the journey, we lose that. We get more fearful of what people will think. Try to let that go. Ask for help. One thing I think is super important to learn is design patterns. And patterns have been used in various different industries for a long time. Patterns are used for templates for wallpaper so that we can wallpaper walls over and over again. It allows things to scale and be done at a much greater scale. The important thing about the design patterns, though, is not that you go off and you read the book and you know all the different types of them. The important thing is knowing where to use them. If you've been to a house that's been decorated horrendously where everything looks exactly the same all over the place, that's a good analogy for using the wrong design pattern the wrong way. That's another important key. One thing that I really wrestle with is that there seem to be these people in computer science and software engineering, the IT industry, who just know how to solve problems. You know, you might have a team that's wrestling with something for some time, they can't work it out, and you wheel this guy in and he just knows instantly where to look, what to do, and he gets it sorted quickly. And I don't think that's by chance. Some of the outages I've experienced that have had me travel across the world at zero notice and end up in Singapore and places like that have really taught me to reflect on those individuals who are able to troubleshoot really quickly. And one of the things they tend to do is they tend to be really empirical about it. And this is something you can apply to your debugging and other techniques, but when it comes to troubleshooting issues, define your hypotheses, test those hypotheses, and then refine based on those. So you'll either proven or disproven those hypotheses, and that allows you to tell which track to go down. I'm sure everyone's been in that position where you've got a group of people looking at a problem and ideas are flung out everywhere and everyone's saying, do this, change that. And when that happens, that can lead to a bit of chaos and it can lead to things changing and you're not sure if it's making worse or better. Bringing a bit of structure, a bit of calm, control, composure, and following those steps really helps with solving any problem, whether it's a crisis or just getting that bug or defect fixed. And the last one, from the learning perspective, is probably one of the most difficult. So I'm not going to go into the details of how you do this, but it's more something you need to do. When I left uni, there was no such thing as emotional intelligence. There was no such thing. There probably was things such as self-awareness, but I wasn't aware of them. And this has probably been one of the biggest things on my journey. And everyone will have their own way of working out how to know more about themselves. But when you do know a little bit more about yourself, whether that's through meditation or other techniques that might be out there, you can realize that you may be projecting your own circumstances onto the situations around you. You might be bringing your own prejudices, your own anger, your own frustration, your own knowledge even. And that can play out in the conversations that you have with other individuals. When you're more self-aware, when you're more responsive versus reactive, then you can have different conversations with individuals. And in my experience, that's really helped me to thrive in my career. We talked about the learning. Now this is more about the doing and more principles around how you might go about this. The first thing for me is putting the happiness first. If you constantly think that happiness lives at the end of the rainbow, it's after I get married, it's after I get the new house, after I get the job or promotion, you'll constantly be looking for that happiness. A lot of people do this, and I myself did that as well. What a lot of research at Harvard is showing is if you put happiness first, then those things come as a byproduct. And people who have that happiness advantage tend to be a lot more successful and a lot more creative in their outlook in life. A really simple thing to think about is, how can you possibly be happy if you're not doing things that make you happy? And that's usually something to reflect on, to work out what you enjoy doing and making sure that you're doing it to get that happiness, and then you'll see your career succeed. And related to that is being yourself, being authentic. Who are you? Don't come to work with a mask. Don't pretend to be someone else. The mask will slip. You'll get tired. You'll get frustrated. And the emotions will come out in weird and wacky ways. Now, there is a caveat to that. Don't think that you are the most special person in the universe and everyone just needs to fall in line with your thinking. This comes back to that self-realization, self-awareness point. When you know yourself a bit better, then you hopefully can determine when you're being a good guy and you're not being the jerk, and you're getting on with individuals while being authentic and being yourself. This is something that I constantly have to challenge myself on, and I think everyone does. And the reality is that it's much easier to put someone down than it is to lift them up. And I know I've been around individuals who kind of lay down the put downs and make you feel not like you're doing a great job. And that's really not constructive. That doesn't help anyone. It doesn't help the individual giving that feedback, and it doesn't help the individual receiving it. And what I've found is it's much more important to lift people up around you, to give praise where it's due, and to really push people forward. Because that'll not just help you progress, but it'll help other people around you progress. Great example of this is whenever you get to high levels of professional tennis coaching, the coaches don't constantly correct individuals on what they're doing wrong. They praise what they're doing right, and they give one or two small little corrections for them to work on. And that's super important, because once they've got to that level, they know what they're doing. They don't need to be told what they're not doing. They already know. They just need a bit more encouragement. One thing I think that puts all of us on the back foot is our fears. And I think the first step is admitting that you have fears and what those are. And everyone's different. Some might have a fear of heights, some might have a fear of public speaking, confrontation, whatever it happens to be. But the first step is understanding that they exist. The second step is realizing that you can overcome them. Realize I haven't said don't be afraid. That's a little bit trite. You can overcome them, and how you overcome them is through things like graded exposure. If anyone's ever been bouldering, you don't jump off a 30-foot cliff into water straight away. You start off with a small jump, and then a bigger jump, and a bigger one, and a bigger one, and a bigger one, building your confidence as you go to overcome that fear and jump off the big cliff. And this is probably one of the hardest tips to bear in mind and to overcome. And that is communication is key. I think everyone can agree that. It's very, very obvious. And it's especially obvious whenever we're working in the middle of a pandemic and you're not talking to people in the office in the same way. You have to be more deliberate about that communication, and you have to be more precise. But one thing I find super useful in that is replaying what I think someone said to me back to them. So when somebody has had a conversation with me, just summarizing up and saying, just to be clear, so what I think you're saying is this, is that right? Absolutely helps you to go away both on the same proverbial page in the same direction, as opposed to both going away with your own understanding in different directions. And finally, to wrap up, a couple of bonus tips. And the first one is computer science does not make you a software engineer. And that sort of ties into the first one of walking before you run. But I'd also encourage people to realize that there's other things you can do. You can be a QA engineer, a QA automation engineer, an SDET. You can be someone in compliance and risk compliance. You can be someone who works in infrastructure and writes infrastructure as code. And some of the most talented computer scientists that I've worked with have went on that journey and aren't necessarily software engineers right now. And then finally is building the community. Being part of a conference like this is a start in that journey. These are super important. When I left for Australia in 2004, there was not much of a developer community in Belfast. I was so encouraged when I came back in 2009, how it was fledgling, and so encouraged by how it has grown over the last decade. I encourage you all to be part of that, to contribute to it, and to continue to learn from it and help others learn from it. Thank you.
Thanks very much, and that was a fantastic talk. Next up on track 1, we have Martin McKeedney going through DynamoDB, and on track 2, we have Kubernetes from, apologies, my memory's not as good as Mark's, James Glennon. So enjoy.
So thanks very much for tuning into this talk about NoSQL databases in general, and more specifically DynamoDB. So the NoSQL debate, we're going to talk a bit today about how NoSQL databases work and why they're maybe thought about in the wrong way and maybe approached in the wrong way. And we'll be using Dynamo as a case study throughout. A bit about me, my name is Martin McKeveney. I'm a software engineer and co-founder of Bodybase, a no-code startup based here in Belfast. So first off, what is DynamoDB? DynamoDB is a fully managed, multi-region, key value and document database providing single-digit millisecond latency at almost any scale. And one thing that's important to note there is the key value and document thing. It's not just for direct key value lookups on single symbol types, but we can have more complex types in there as well. So before we get into any of the DynamoDB stuff, I just want to go back a little bit and talk about databases in general and their kind of progression through the years and how we've got to this point. So relational databases are the natural place to start. Relational databases are a wonderful technology. They're pretty simple to pick up. They're extremely common and they're super flexible and pretty much the default choice for pretty much most applications nowadays. And their flexibility comes through the use of joins. So you create your data in different tables. You might have a students table and a classes table. And then whenever we query that database, it finds the rows in each table, scans them, and decides which ones to join together, and then returns them to the client. So one of the other features of relational databases is referential integrity. And essentially that lets us make sure that our data stays, we have good integrity of our data. So in that student and classes example, we can't delete a class that has a bunch of students. We can't add a student to a class that doesn't exist. So it's good in that way. It's also very vertically scalable. It's always easier to bump up your database instance and add more memory and CPU. On the other hand, the part that makes relational databases flexible and powerful is also its bottleneck when it comes to performance. Joins can be very costly and very unpredictable at scale when it comes to performance. As your data set grows or you've got lots of different queries running at the same time against the database, things can start to get slow. And it's quite hard to plan ahead for this. You can create indexes and things like that, but it's almost impossible to plan for scale with relational databases in some cases. SQL queries are also boundless, so there's no limit as to how many rows can be scanned as part of a query. And that's not just your results, you can limit those, but you can't really limit how many rows get scanned. So it's very easy to write a very bad SQL query that can use a ton of memory and CPU and potentially crash your database server. Also, horizontal scaling is quite hard. Horizontal scaling is easy whenever you can set it up in such a way where a single request gets served by a single node or partition. This is very hard to do in relational databases, and you usually find that data, you're jumping about from left and right and paying the cost of network latency. So over the past sort of 2-3 decades, NoSQL databases have become quite a big thing. And they were essentially invented to handle the scale and throughput that SQL cannot. There's no concept of joins in NoSQL databases. They've kind of done away with that whole thing because it is the bottleneck after all. Data is segmented into different partitions and it makes it easy and fast to access it at large scale. And one of the things that NoSQL databases are optimized for is CPU. Back when relational databases were invented, storage was the most expensive thing in the data center. That's no longer the case, it's now compute. So NoSQL database is optimized for this and it makes sense. So how does a NoSQL database work? This is the architecture here of a Dynamo table, but it really applies to most NoSQL databases. They're pretty much all set up this way. And really, they use partition keys or segments to decide which node is going to serve which request based on the data that you're inputting or reading from the database. So in this example here, we've got the DynamoDB request router and a few nodes. And you can see that these nodes have a particular set of user IDs that they're responsible for. So like, 1 to 300 or so. And then whenever we go to write some data into there, it checks the partition key, in this case 741, and based on that it decides which node it's going to be stored in. So why is this useful? It's useful when we try to read data out of the database. So when we try to read out the user ID of 741, the DynamoDB request router knows which node to go to. And this is good. This means that we can scale almost infinitely and just keep creating more and more little partitions and nodes. And based on that key, we then know which node is going to serve which request based on those keys. So one thing that is very, very common for people who are making transitions from relational databases to NoSQL is they try and apply what's known sometimes as Faux-SQL. And that's they try and apply relational patterns to data in NoSQL databases. And that doesn't work very well, and it certainly doesn't scale. So flexibility is one thing that is brought up quite often when it comes to NoSQL databases. But really, it's more of a sales pitch. They're not really meant to be like that. It's not meant to be schemaless, add whatever schema you want. You know, it's not meant to be like that. It's actually extra work up front, and you need to define your access patterns if you want your NoSQL database to scale. It's a pretty easy way to think about it when it comes to NoSQL versus SQL databases and where they're applicable at large scale is the difference between an OLAP and an OLTP system. An OLTP system, or an online transactional processing system, takes transactions and writes them in real time and stores them. An OLAP system, or an online analytical processing system, runs analytical queries and on historical data generated by OLTP systems. So OLAP systems are a better fit for SQL because you need that flexibility. You need to be able to do aggregations and roll-ups on that historical data, whereas OLTP is generally a pretty good fit for NoSQL. And if you find yourself trying to use a NoSQL database, doing tons of different tables, loads of joins, and writing all that yourself in your own code, there's no point in that. SQL databases are optimized for this and have been for decades. So, you know, it's quite obvious when you need to use a relational database or when you're using a NoSQL database wrong. So, with that said, DynamoDB. So, originally, Amazon.com was run on a full Oracle infrastructure with Oracle databases, and they eventually reached a bit of a sort of tipping point with this. Even though they had access to some of the premier experts with Oracle databases, Oracle themselves, for example, they started to hit bottlenecks, as you could imagine, at that kind of scale with Amazon.com. So what they realized was most operations were actually key value operations, over 70% in fact, and they were operating on single values, or if it was over multiple rows, it was in the same table. So Amazon decided to go off and build their own database to solve this problem. They went and built Dynamo in-house, and they released the paper in 2007 after they'd implemented it themselves for Amazon.com. And the paper had some really highly novel and influential ideas around distributed systems and NoSQL databases, and it influenced quite a few other offerings, like Cassandra from Facebook. Amazon then took that Dynamo service and wrapped it up in a managed package that they deployed on their AWS platform in 2012. Since then, Dynamo now serves well over 1 trillion requests per day, and it's used by companies all over the world, from multinational conglomerates to small startups. The likes of Lyft use it to store GPS locations for their rides. Tinder uses it to store millions of user profiles and billions of matches. BMW use it for cars as sensor services. Under Armour use it to support their fitness community of over 200 million users with the MyFitnessPal app. And Toyota Racing use it for real-time decisions on pit stops and other racing data, as well as other 100,000 other AWS customers. So why is it so popular and why is it growing so fast? There's a couple of benefits to using DynamoDB. One is that it's durable and highly available. As we saw earlier, it splits data into different partitions or nodes, and these nodes are then replicated across availability zones. So if there's a natural disaster or something goes wrong, you won't lose access to your data. It's highly performant for the same reason. We're able to partition data and understand which request gets routed to which node, and it keeps things very fast. It's fully managed. You don't need to worry about scaling things up and down. You don't need to worry about managing infrastructure. That's all done for you. It has adaptive capacity. It's able to scale up and down, or you can actually set up how much usage you think you're going to use and have significant cost savings because of that. It's also able to adapt in the sense that as your data starts to grow, it'll split off into more and more nodes and more partitions, so you don't end up with enormous partitions and damaged performance. Access control, we have pretty highly granular access control. at the table, attribute, and even item level. So that's good for security purposes. And we have the concept of bounded queries, as we talked about earlier. Relational databases don't have this. They have bounded queries in DynamoDB. So if you request a result that's over 1 megabyte, it'll actually give you a pagination key back, and you have to paginate through that in the client. So it won't let you request a huge amount of data in one go. DynamoDB essentially won't let you write a bad query. And by bad query, it means a query that won't scale. So let's dive into the basics, the basic building blocks of Dynamo. The first is tables, and they'd be familiar to anyone who's used relational databases. They're just a grouping of data records, users, dogs, cats, whatever it may be. We have items, and an item is a single data record in a table, and they're uniquely identified by a primary key, and we'll get into that in just a moment. So you can see here we've got a user record with a primary key of user ID, and they're just like rows in SQL. We have attributes, and attributes are pieces of data attached to a single item. They must have a type, so there's scalar types like string and number. There's document types like maps and lists, and then we have sets, which are just sets of multiple scalars with no duplicates. So you can see here an attribute, and one example is an age, and these are like columns in a relational database. So primary keys, there's two types of primary keys in Dynamo. There's a simple primary key, which is just a single attribute, and that attribute gets used as the partition key. So you can see here, like the user ID example, that's a simple primary key. We have then a composite primary key, which is made up of two different attributes. So we need to make sure our primary key is unique, and in some cases, a partition key alone isn't enough to make it unique. So in this case, we have a partition key of product ID, and we have two items with the same product ID, so we need another attribute to make it unique. In this case, we add another attribute called the sort key, and then that's used to distinguish uniqueness between records. So you can see that the ones with the same partition key have a different sort key and therefore are unique. And this becomes very handy in future when you're trying to query on a partition key. You get the sort key attributes sorted automatically for you, and that comes in quite handy. So let's dive into an example. Pretty much everyone here has probably taken their car through an MOT at some point. And the MOT, for those who don't know, it's basically like a checkup for your car once a year to make sure that it's roadworthy. And you get a letter in the post, you get told which centre you're going to go to, and they have these big gates, and you get told which gate you need to go to and at what time. So we'll use this to, as an example, and start to model an MOT appointment system using DynamoDB. So first off, we'll create a table. We create an MOT appointment table, and we need a composite primary key. The partition key is a center gate, so Belfast, gate 3, for example, and then that's not enough to distinguish uniqueness. Lots of cars might be at Belfast, gate 3, so we need another attribute to make it unique, and that's going to be the time. So we make the time the sort key. So after we create our table, we can start to put some records or items in there. We put an item that's Belfast, gate 2, at a certain timestamp, and then we say the make and model. And in Dynamo, you'll notice we didn't put down what our fields were, apart from the partition key and sort key. Dynamo doesn't care about that, it only cares about your keyed attributes, so you can add as many other attributes as you want. So we put in this item, and the router then knows which node it's going to go into. This is a bit of an oversimplification, but it would put it into a node based in the partition key, so in this case Belfast 2. We then start to add some records in there, so we'll add some some MOT appointments for Belfast gate 2 at a certain time, and Newton Ards gate 1, and we'll start to add some extra items in there. So if we want to query these out then, and say, give me all the MOT appointments at the Belfast test centre at gate 2, ordered by time, all we have to do is ask for the Belfast 2 partition key, and it'll give us all the items that are partitioned by Belfast gate 2 and organized and sorted by time ascending. So you can see how we can write simple, easy queries by keying things properly and knowing our access patterns up front. So this is how you would actually express this using the AWS SDK in JavaScript. And you can see here how we have a function to query our items. We pass in our table name, which is MOT appointment. We have expression attribute names and expression attribute values, which are really just the keys and values that get interpolated to the key condition expression, which is the query itself. So you can see here that we can just query the items by querying by the partition key, Belfast 2, and that'll give us all the MOTs and the Belfast Test Centre, Gate 2, or organised by time. So before we dive into a more advanced example, there's a couple of other concepts to understand about Dynamo that come in useful. One of which is consistency. So consistency is a very common topic in distributed systems. There's strict consistency and eventual consistency. Strict consistency means that data will always be up to date. You'll never have anything stale. Whereas eventual consistency is that there's a potential that you might get stale data, even if it's only for a short time. Dynamo, by default, is eventually consistent. Usually the data is updated within half a second or so, but sometimes if you do a write and read instantly, you might get stale data in that case. But in a lot of systems, that doesn't really matter all that much, unless you're talking about bank transactions or something that relies very heavily on strongly consistent reads. Twitter feeds or social media feeds or anything like that, it doesn't really matter if you get data that's half a second stale. So where this comes in important is when it comes to cost. In Dynamo, you don't pay for an instance or a size of an instance. You pay for how much you read and write. So we have read request units and write request units. A read request unit that uses a strongly consistent read uses 1 unit, whereas an eventually consistent read uses half a request unit. So it's actually double the price to use strongly consistent reads. A write request unit, it uses 1 to write an item up to 1 KB and uses more for anything over that. So you want to make sure you're not putting huge amounts of data in with your writes. So query in Dynamo. In the previous example that we saw, you can only query index data in Dynamo, and we did that. We queried by partition key, where you could use the sort key. They're both indexed fields. And this is how, again, it stays fast and scalable. We can't query non-key attributes without doing a filter. So a filter will filter down the results after the query, meaning you're paying for all the rows you query before the filter. We want to avoid this. So, for example, if we tried to do a filter or we tried to query on the make or the model of the car, it would actually query all the rows first and then filter them after that. So we pay the cost for all the reads because we didn't use keyed attributes. So we want to try and avoid that. It doesn't really matter for small databases or small use cases, but as you start to scale, it can get very pricey and very slow very quickly. And the way that we avoid that is we use indexes. Indexes let us specify alternate key structures that we can query on to keep things fast. They give us increased query flexibility. So, we can query our database in different ways. We can avoid scans and filters, and therefore, the cost and performance hits that we would pay by using those. And the downside is that we need to pay for extra writes to those indexes. So as we write data into the table itself, it's also going to write the relevant data into those indexes also. So there's 2 types of indexes. There's a local secondary index, and they can only be used on a table with a composite primary key. And what that lets you do is specify an index with the same partition key, but a different sort key. So in this example here, we have a table with the partition key as user, and the sort key is image. But if we wanted to change the sort key to date, we could create a local secondary index to do so. And they need to be defined on table creation. Global secondary indexes, on the other hand, are a little different and a little more powerful and flexible. They can be defined whenever we want after table creation, and they can be used to specify a completely different table or key structure for the table. So in this example, we've got a table name with songs keyed by song ID. We could create a global secondary index or a GSI for the genre, and that's sorted by number of likes, or we could create a GSI for the singer ID and sorted by the launch year. So you can see how it gives us a little more flexibility in how we query our data, and we can avoid doing those scans and filters. So a few best practices before we dive into the last example. Know your access patterns up front. Try and pre-join data and get it into a single table. We really shouldn't be spreading things amongst many tables and having to join them together. Select indexes up front if you can, and try and understand which indexes you'll need ahead of time. You should pretty much always go for eventually consistent reads. They're half the price, they're much faster. You don't have to wait for data to be, all the data to be not stale before you query it back out. We can avoid filters and scans, and you should also try and avoid or you should also try and abuse IDs. Try and pack as much data into your keys as possible so you can query them in different ways without having to pay the cost of creating more and more indexes. So we're going to model a hierarchical example, and this is a very popular one with SQL databases. It's usually expressed with a bunch of joins and a bunch of different tables. So we're going to express a employee database, like a worldwide employee database. And we're going to have company, and we're going to have departments within that company, and then we're going to have offices within those departments, and finally job roles within those offices. So step one, if we were to model this with Dynamo, we need to identify our access patterns. First of all, we need to be able to retrieve a single person by their employee ID. We need to be able to gather all people in a particular company. We need to be able to gather all people from a certain department within that company. We need to be able to gather all people in a particular office within that department. And finally, we need to be able to gather all people with a certain job role in that office. So we can set about creating our primary keys based on those access patterns. First of all, we need to choose a good primary key that enables us to uniquely identify everything for writes and updates. And we want to evenly distribute our data across the partition key. So we don't want lots of keys that are the same, so we don't bunch up and get shards that are what are known as hot. So we can start off by creating a basic, simple primary key on an employee ID, and that satisfies the use case of just being able to fetch an employee by their employee ID. The next step is we need to define our indexes. So we know that we need to be able to get people by their company as well as their department, office, or role. So we can create a single GSI for this with a partition key of company and then a sort key named department, office, role. So you can see how we're starting to abuse IDs and pack in as much data as possible. We can have a partition key of company, and then we can create a sort key for department, office, and role. So engineering, Dublin, VP. So we create our index. And then this is how we start to query this out. Pretty similar to the last example. The only difference is that we have an extra key. So we are able to query our company. So we'll be able to give a company like Stripe, for example. And then we can also pass in our department, office, role. So in the first query, you can see we pass in Stripe with no sort key, and that'll just give us all the people that work on Stripe, and then their sort key will be automatically sorted. So they'll be sorted by department, office, and role automatically for us. In the second example, we query for employees who work in engineering in Google's Zurich office. So we could do that by asking for a Google partition key, and then engineering #Zurich for the engineering department and the Zurich office. And you can see in that query, we have a begins with. So company equals company and begin with department, office, role. So we can actually just check if the sort key begins with something, and it gives us flexibility around querying with a single index. Finally, we want to query an item based on not just department or an office, but job role as well. So if we wanted to fetch all the people who work in Intercom, in UX, in San Francisco as a designer, we can query that with the following, Intercom, and then UX #San Francisco #designer. So you can see we have that flexibility just from using the single index. And the powerful thing about this, as we start to query it, is that this is essentially scalable over like millions of rows. So if you had a genuine worldwide employee database, you could query them for all those things with essentially single millisecond latency. So that's very powerful, especially considering that you don't have to worry about scaling or managing any of this and being able to achieve that kind of speed fairly consistently over time. So in this example, we're just querying for Stripe, and we are looking at the engineering department and the Dublin office. And you can see here, this is how the results come back. Everyone in Dublin in engineering is listed, and the sort key just orders them by their job role. And that's it. Thank you very much for listening.
Okay, thanks very much for that. That was great. Now, as they say, for a message from our sponsors. One of our sponsors is Rapid7. They've got a talk coming up tomorrow from Arnaud Roger, I think. Don't ask me how you pronounce these things. But yes, we'll be just running a quick video from Rapid7 about what they do.
Hi, my name is Lauren Hughes. I work as a software engineer here at Rapid7. I'm a front-end developer, so a lot of the technologies that I would use on a regular basis would be JavaScript, TypeScript, and usually with a React framework. As a woman in tech, I recognise that I am pretty much a minority in this industry. And it's important to me to know that I'm with a company who recognises that that is an issue. Rapid7 has made initiatives to recognise all minority groups within the tech industry, be that because of your gender, because of your race, your age, and they have got behind a lot of STEM projects for kids in kind of secondary schools to do workshops with us to introduce them to the life of coding, hacking, doing like small hackathons with them, and I think it's a really important part of knowing that a company that you're working for is doing its best to shape the future youth of tomorrow and the people that they're going to hire in the next 10 years. And I think it's a really something that I really would have benefited from when I was at school. So that's something I'm definitely behind, and I think yet another reason that it stands out as a company in this industry. I would recommend anyone to work at Rapid7. Honestly, you know, the people that work here are not only incredibly talented at what they do, be that from a technical aspect, managerial, you know, even from leadership and right up, but there is such a sense of community. There's never a wrong question to ask anyone, and there's a real sense of family.
Fantastic video. So we have a second sponsor video for you as now. This one's from Signified, and they actually have their own talk tomorrow as well, and it really has probably my favourite title, Well, 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 What Do We Have Here by Mark McKenna. So looking forward to seeing that one. But just for now, let's have a look at what Signified does.
The Belfast office is not just an engineering centre. They have our risk team, data science, so it's kind of that they're growing the whole office as opposed to just that kind of engineering side of things.
So the main technology I'm using at Signified is mainly Java-based languages along with Amazon Web Services and the likes of Cassandra for a database.
We are deployed within the cloud, so we are a SaaS-based company. We leverage Kubernetes and AWS. The thing to say really about our tech stack is I can tell you what we have today, what we have tomorrow. I can't tell you, but we are continually evolving that tech stack so that it meets the business and technical requirements of the platform.
It's quite a challenge. You're building things from the ground up. So other companies might offer like, you know, just like fixing old products or kind of adding new features on, whereas we're building things from scratch.
One of the things that attracted me to Signified was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team means you're not getting lost in, you know, a load of people. It's one of the most attractive Java opportunities in Belfast.
It's an agile environment where there's 2-week sprints. So really anybody can get up and take a task on the board and take it right through from design to implementation all the way through to production.
everybody chips in, so there's a hands-on approach. So you're involved from the design, DevOps work, and testing as well. So there's a real kind of broad spectrum of work you take on.
We roll up our sleeves, we get on with it. Nobody at Signified will tell you how to do your job, but we're all there to support each other and make sure that we're all making the right decisions. If anybody needs help, we're not afraid to ask.
Every year Signified hold on-site meetups for everybody in the company to kind of gather in San Jose. So in May I got to head out for a week and participate in a hackathon and different activities for it.
You do turn around and help other people, you come together, and it's quite like a family in that way. It's got a lovely environment to it, and it's a lot of hard-working people, which I really value that really highly.
Right. Okay. So apparently we have about 5 minutes before the next talk, and we have no more sponsor videos to play right now, so we're just going to kick back and chat, aren't we, Janae?
Of course. Well, the funny thing was we were talking about meetups earlier.
Yes.
And I remember the story of how NIDC came about. So I've heard it being called a meetup of meetups. So
Yes, well, I mean, basically what happened was I was down in Farset, as many people are quite often, and Phil was down in Farset, as he nearly always is. And we got chatting, and Phil had actually come along to see something in the .NET meetup, even though he's not really a .NET person at all. And I had been to go to the Blug meetup, even though I don't necessarily spend a lot of my time in Linux. And we had agreed that one of the things about going to meetups was, it was actually better to go to meetups that had nothing to do with what you were doing, because that was how you learnt new things. That was how you managed to broaden your outlook and see, things that were going on in other spheres, which would bring, knowledge back to what you were doing yourself. So at that point, we sort of started having this idea that we should get something together, where we would try and bring people in just to see all sorts of random things that would help them learn, and not always go for this sticking in your silo sort of thing. So that's essentially the genesis of NIDC, is just this idea of having a huge meetup where all the other meetups would come in and talk about their things, and everybody would learn. So, and yeah, I do encourage everybody. I have recently inherited, just before lockdown, the Belfast.net meetup, which we were just trying to start up, and I'm also now the co-organizer of the Belfast Azure meetup, so I do encourage you to sign up to those, because they're both going to be really good and have some really good meetups. Also, I have been asked to mention that GDG, the Google Developer Group, I think. Yes, Google Developer Group. They are sort of asking you to go along to their things, and in particular, they're running a thing called DevFest, which is completely free, open to everyone, talks at the beginner and intermediate levels. So if you want to learn about the Google side of things and you're on the Azure side of things, go ahead to that. And if you're already on the Google side of things, come along to the Azure things.
But I mean, we have a really, really healthy meetups.
Yeah, I mean, that is one of the best things about Belfast is, it's just the right size. So there's enough people and enough things going on that, that you've got something for everybody, but it's not so huge that you can't get to things. I mean, I'm talking in the old physical world here, of course, but yes, there's just the right size of ecosystem going on here that, you can cross-pollinate in that way, and everybody knows a few other people, and it just builds, it's just built a really nice size of community that's going on here.
That's it, and even with COVID, many of them have gone online, and we've been able to sort of keep things going. I know Blug is going, and there's, I think, Belfast JS is still going, and a few others as well. Names escape my head, but I don't know, your memory's better than mine.
DevOps meetups going on recently.
And Neri Digital, I know, has started back with
Oh, right.
force. So one outside of Belfast. You know. But yeah, no. So
yeah, I mean, I know I keep saying Belfast. Obviously, I'm from way up on the north coast, so but Belfast and Northern Ireland are
pretty much
and sometimes easily confused.
That's it. But yes, we're now on to more talks. We're not going to bore you anymore about meetups. So we now have the fantastic Phil Wilkinson of Flexera. He's going to speak about leadership in tech. And
on track 2, I think it's Dan Porter-Wilgar,
yes.
isn't it? And he's going to be talking about coding for a live streaming platform. So, we could have done with somebody like that this morning.
We need more dance music. So, enjoy.
Yeah. Okay, so Phil, you're over to you.
It's Monday, the 10th of December 2018, and I'm on an Aer Lingus flight landing into Chicago O'Hare at about 2:30 in the afternoon. And at around 4 p.m, I'm going to be arriving at Flexera headquarters. My first appointment is a one-on-one with my boss. And at that meeting, I'm expected to share with him my plan for delivering Flexera's next generation platform within the next 12 months. So here I am. I'm sitting across from him, across his desk, and he asked to see my plan. I know the plan sucks. I know it's going to fall well short of his expectations. But I worked with the team for the last 5 to 10 days. It wasn't a long time to try and pull together a 12-month plan, so we did our best. We're dealing with a huge amount of technical uncertainty and product uncertainty. And so this is it. This is the plan. So Art asked me to share it with him. And I still remember his words. He said, "Phil, I don't question your effort. I don't question your work ethic, but I just don't understand your decision making." And this was the first time in my career, albeit quite privileged, that anyone had questioned my ability to potentially do my job, especially as something as fundamental as decision making. And it hit me squarely between the eyes. Roll on a few weeks, and Art calls me, we're on a video call, and he says, "Phil, I'm sorry, but we have to take some of the open recs you're hiring for, and we have to put them elsewhere in the business. We need the budget." And I argue with him. I say, "Look, Art, you just rejected my plan. If we're going to accelerate this, we have to hire these roles." But the decision was already made. I didn't let it go. 3 days later, I found myself in a video call with my CEO. And I was determined to change Jim's mind. I didn't. In fact, it was a car crash of a conversation for me. I was so tunneled and blinkered in my own thinking that I came away from that conversation looking immature and foolish. I was done. How was I supposed to be successful at Flexera when my boss doesn't believe in me and the business doesn't want to invest in my teams? Folks, I'm Phil Wilkinson, and I am still Senior Director of Engineering at Flexera. I lead the data business segment. I'm responsible for 5 different products across the business, leading around 140 engineers. We work on everything from C++, C#, .NET. We work on relational database technology, right through to really modern event-driven microservice architectures running on AWS and Kubernetes, Kinesis and Dynamo and Mongo, and I could go on. I came to Flexera through their acquisition of a smaller company called BDNI, based in California. And BDNI hired me to establish their Belfast office, to build a new team, and to develop their the next version of their product. But I actually fell into tech by accident. I was graduating from Queen's in 2006 with a degree in mechanical engineering, and I was aware at the time that engineering really wasn't going anywhere in Northern Ireland. It was very much in the decline, so I decided to try something different. And I happened to be given a place on Citigroup's graduate scheme. And my very basic CV at the time made one mention of access from a university project, and so they put me onto a data warehousing team, and there my fate was sealed. It was at Citigroup that I developed my love of data and tech in general. September 2008, I remember being called very late in the evening by my boss's boss's boss and asked, could I come into the office? He needed my help to run some reports to figure out just how exposed we were to the collapse of Lehman Brothers. What a remarkable couple of weeks that followed. I remember the following Friday watching the Bloomberg terminal on Sky as Citigroup's own share price plummeted towards $1 and wondering whether I was going to be going to work on Monday morning. And for me, it was during that time that I realized that technology is not the end in itself. Technology is about outcomes for your business, for your charity, for your organization, whatever it happens to be. And ultimately, it's about outcomes for real people. I stayed with Citigroup for another few years. I eventually left to join Oracle, where I spent 5 years as a data warehousing specialist. I left there to join BitNet, which is a Bitcoin payment processor startup. Unfortunately, that only lasted for me about 9 months before I was made redundant. But during that 9-month period, I was exposed to a new way of thinking about engineering, a new style of culture for an engineering group, and most importantly for me, a new style of leadership. Shortly after that, I went back to Citi for 9 months, and then the BDNA opportunity came along. So what is leadership? Over the next 30 minutes, I want to share some of my thoughts on leadership that I've learned along on my journey. And for the purposes of this talk, I'm probably going to conflate the idea of management and relationship. I know of many brilliant leaders, management and leadership, and I know of many great leaders who are not managers. They're individual contributors. And a lot of what I'm going to say is going to be relevant to you if you're in a role like that. And equally, I know of many managers who really struggle with leadership and therefore really struggle to find success. And so I'm not going to get hung up on the terminology. Ultimately, to be a great manager, you need to be able to lead. So where do we start with leadership? Well, let's start where all good engineers start, and that's with the acceptance criteria. Whatever level of leadership you're at, you're going to be measured on 2 things, and probably 2 things alone: performance and attention. On the performance side, are you setting ambitious but realistic goals? Are you meeting those goals? And are you building and maintaining strong teams and managers of teams? On the retention side, are the people in your teams engaged? Do they feel valued? And ultimately, are they staying with you? So it's checks and a balances thing. One side, you want to get the best performance out of your organization as you can. But then on the other side, you want to push them so hard that your team just want to get out. And achieving that balance is very risky and difficult. Within tech, the days of command and control are over. For the most part, organizations have discovered that the best performing teams are those who have empowered their employees. Their employees understand the business, they know their users, they know the outcomes, and the teams are free to develop the solutions to meet those outcomes. But for this to work, you need a highly motivated team of individuals, engineers, product people, marketing, sales, etc. They will need to understand your business, and they need to feel motivated to deliver for you. And for that, you need to be able to cultivate a culture. Now, back in 2016, whenever I became site leader for BDNA, I remember a few weeks in, one of our senior leaders in California posted us across a tiny bonsai tree. It was to celebrate the opening of our new office. And for the first couple of months, it was easy to look after this tree. There was only 5 of us in the office, and so we just watered it every few days. It was fine. But as more and more people joined the office and the office size grew, the poor bonsai tree in the corner was starting to look a bit dry. The leaves were starting to fall off. Everyone thought someone else was watering it. And so we talked briefly about how we were going to keep this tree alive. And I can't remember who it was, but someone suggested, you know what, the best thing we should do is we give it to the next new hire. They'll look after it. And that's what happened. And for months, years after, the next new hire into BDNI was handed this plant by some random colleague on their first day with the words, "Don't kill the bonsai tree." Now, over some time, I started to realize that this tree was a great analogy for what I was trying to do with our culture. At BDNA, I was trying to form my team and the organization around the ideals of trust and respect. And I began to understand that I can't force that culture. I can demonstrate it, I can teach it, but ultimately it's not up to me for those people to adopt the culture. And so for every new person that came through my door, I was essentially handing my culture to them and saying, you can be part of this, and what you do with it is up to you. You can help improve it, nurture it, or you can neglect it and let it go to waste. So just like the little bonsai tree got placed on someone's desk, so too were we saying to those new people, here is our culture, be part of it, and help us improve it. And so to develop that strong culture of performance, you really need to be selecting the right people and keeping the right people in your business who are reflective of the culture that you want to develop. Now, despite doing everything that you can to create a culture of performance and retention, it's not always going to be easy. In fact, being in leadership can often feel like you're trying to run a marathon through treacle. Remember about 6 months after our acquisition by Flexera, we had a number of people in the Belfast team decide they wanted to move on to and leave Flexera. Now, I expected this, I knew it was coming, and I knew it was just part of the transition into a larger organization. So I got my head down, pumped myself up, and went and rehired. And we rehired some fantastic people. They elevated the level of our team, our velocity increased, and I patted myself in the back, thought, yes, done it. We've got over the acquisition hump. And a few months later, as an organization, we decided that the project that my team were leading was so critical to Flexera's future success that we needed to make it a global effort. We needed to bring in other teams around the world to help us deliver it on time. And I knew that despite this being the right decision, this was going to leave my teams feeling somewhat disenfranchised. This had been our baby for 2 years. And a number of months later, we had another few people decided to leave us, and I was completely deflated. But I did it again. I got back in the saddle, pumped myself up again, and we rehired. I even found a member of our team who was a real shining star, and I identified them, and I thought, that's our next manager. And so I started to invest in that person to groom them for leadership. And they knew it was coming. We'd been talking about it. And on the day that I was going to tell them that they were promoted to team manager, they got ahead of it, and they told me that they were resigning to move overseas to take up a great new opportunity. I really started to ask myself, what am I doing wrong? Am I actually up to this job, or have I bitten off more than I can chew? With every setback, I started to find myself having to dig deeper and deeper into my reserves of energy. My emotions were running out, and it was becoming difficult. Not only having to manage my own disappointments, my own fears, but also trying to bring this large team along with me. Call it whatever you want. Grit, resilience, tenacity. It doesn't come easy, and I don't think any of us are born with it. I know that I certainly wasn't. But as my leadership roles have evolved, I've found myself having to really start to work that muscle as my roles have developed. In 2018, I was trying to figure out how our platform was going to become part of Flexera's architecture. We were really struggling. We had engineers in Belfast talking to engineers in Melbourne and Itasca, Chicago, and we were trying to figure out how all these pieces came together. We knew that somehow this platform was to be a linchpin between everything, but we just couldn't quite figure out the moving pieces. And all I really wanted to do was take a few engineers from each of these main teams and just put them all together in a room for a week and allow them to develop this solution. And so I went to Art and I said, Art, we need to get 20 engineers. We're going to fly them to Itasca. We're going to put them in a room for a week and we're going to have a summit and bring together this technology. We're going to figure out the architecture. It didn't happen. I couldn't convince Art of why this was a good plan. A year later, we acquired another company called RightScale, who are based in Santa Barbara, California. I'm not jealous. And shortly after that acquisition, I was talking to some of their engineers, and they were telling me about the internal engineering conferences that they would have run whenever they were a smaller company, and BD&I did something very similar. It was all about bringing people together, forming relationships, building trust between engineering teams, and collaborating around technology. And I thought, look, Flexera needs to be doing this. This is what we need. And so I tried again. I called Art. I said, Art, we need to do this. We get 40 engineers into a room, and we're going to have an engineering conference. We're going to run a hackathon. And we're going to take some real business problems and spend a week and come up with some real solutions. It didn't happen. I convinced Art. Art was behind it. But I wasn't able to build a business case that was going to convince our CFO and our CEO to sign off on the check. But 6 months later, an opportunity arose. We acquired another company called Risk Networks, who are based in North Carolina. And shortly after that acquisition, Jim, our CEO, was talking to some of the engineers, and it transpired that the engineers were investigating the use of graph databases. They didn't know that the engineers in Belfast had been using graph databases for quite some time. And Jim was a bit frustrated about this, and he said to Art, what do we do about this? Our engineering teams don't know what's going on across the organization. It was Art that saw the opportunity. And so in August 2019, I pitched my third attempt. And this time I pitched it straight to Jim, face-to-face in Chicago. And on January 2020, Art opened Flexera's first ever internal engineering conference called Fest 2020. To 140 engineers, 75 of whom had flown in from different Flexera locations around the world. We spent the week having engineering talks. We did an unconference. We did a design thinking exercise. And the engineers spent most of the time doing just like what we're doing here at NIDC, doing engineering presentations. And this was undoubtedly the highlight of my career to date. It still is. But it took me 2.5 years to convince the right people that it was an idea that we should pursue. And I left Chicago that week with an immense sense of pride. So change often takes time. Even if you've got an idea that you think is clearly valuable, it doesn't automatically mean you're going to get a clear run to deliver it. Any change, whether if it involves any kind of investment or any kind of risk, especially in your organization, what you're really dealing with is hearts and minds. So you're going to often come across these roadblocks, and if you're a leader, it's up to you to decide what to do about those roadblocks. Do you go over them, around them? Do you try and move them? Who can help you along the way? Who can help you convince your stakeholders? Who can help you build the business case justification to get the decision makers to help you move this along? How many times do you try, and do you ever reach a point where you just have to give up? And don't underestimate the importance of timing whenever you're trying to build influence. Many times people on my team will come to me and they'll make a request for investment. It could be for training, it could be for a salary increase for someone on their team, it could be for a new piece of technology. And if I agree with them, I'll often say, yes, but wait, be patient with me. And that's often because I'm trying to find the right time to take this to the decision makers who can help us make it happen. Often I'll be aware of things that are going on in the business that other people might not be aware of. I might be aware that a key decision maker is going through something right now, and if I bring it to them today, they're just going to say no. But if we wait 2 weeks, we're going to have a much better opportunity. So being a leader ultimately requires resilience, and it doesn't come naturally. You need to develop it and nurture it, and you do that by getting up whenever you get knocked down, and not giving up whenever you encounter your first hurdle. And if you'd asked me 4 years ago if I was able to deal with some of the situations that I've come across in the last number of years, or made the decisions, impossible decisions that I've had to make, I'd have laughed at you and said, no, that's not the type of leader that I am. And I believe that the ability to influence is one of the areas which, as an industry, we are failing our engineers. And we have to help our teams develop it. I think a lack of influencing ability is a barrier to many engineers to progressing into more senior roles. I think it's also the source of much frustration in engineering teams who aren't able to convince their stakeholders about what are potentially some really excellent ideas. It doesn't really matter what the goal is. It could be a plan to buy some tech. It could be to build a new team. It could be to run a design thinking experiment on a new feature. It's important that before you make your pitch, that you identify who those stakeholders are. Which of those stakeholders are the ones that really care about what you're doing? What are their goals? And how does what you're proposing help them achieve their goals? But there are other stakeholders who just have power. And you have to identify those stakeholders who may not care about what you're doing, but ultimately hold a lot of power over your ability to deliver it. And once you've identified them, you need to start working with them, usually one-on-one, taking the time to get their feedback on this idea. And then once you start feeling that momentum building with those individual stakeholders, then you can make your pitch, and hopefully you'll have enough support behind you to see it through. This just takes time, but it also, more importantly, requires great relationships. Get to know how your boss works. If you have a PM or a strategy lead, get to know them too, and have questions or have conversations with them about the dynamics of the business that they're dealing with. What helps or hinders them so that you can understand how you can help them with their goals. Go the extra mile from time to time for these folks. Deliver a feature they weren't expecting, give them a few hours consultancy to try and help them solve a problem they're encountering. Because you never know whenever it comes to your turn to have to ask for investment or a favor, that they may be the people that can help you get it across the line. Nothing builds stronger relationships than being authentic, listening to others, and not being afraid to have a laugh with folks and not taking yourself too seriously. Now, there's a different phenomenon within leadership that I wasn't aware of whenever I started out my career as a team lead. I only really started to understand it properly in the last number of years when I started navigating the organizational structures at Citigroup and at Flexera. And the phenomenon is, I'm not even sure if I'm saying that right, phenomenon. The phenomenon is that over time, teams start to mimic the behaviors of their leaders. It's often referred to as the shadow of the leader. So if you're a leader, a manager, a product lead, it doesn't really matter. If you're a leader, then you're in the spotlight and you're casting a shadow behind you. That shadow can be big and strong. It can be narrow and weak. It can be good or it can be bad. But whatever it is, your team are going to respond to it. So what a humbling thought it is that as a leader, the side of the bed that you wake up on in the morning is going to have a direct impact on your team. And I mentioned a few minutes ago about the time that I had to give up on the open recs I was hiring for. Well, the next day I had to communicate that to my team. And so I got the team together in our breakout area, and I told them what was going on, because they all knew we were hiring, we were trying to get referrals, etc. And I told them, look, here's the business context, here's why it's happening. But they could tell. They could tell from my face, they could tell from my eyes, they could tell from my posture. I was not happy. I was still dealing internally with the frustration and the anger and the fear of that decision. I hadn't quite understood myself how I was going to get over it. But in the next couple of days, I was fine. I got back in the saddle, pumped myself up again, and got back to it. But when I arrived in the office, and I looked around, all I saw was groups of demotivated people. What was wrong with them? So only looking back and starting to understand the psychology of leadership, I now understand that I was looking at myself. Those teams had seen how I responded to that situation, and they were mimicking the behavior that I had shown them. It took me months to lift the team out of that feeling of frustration. I needed to remember that as a leader, I should have acknowledged that this was a setback. I'm not going to lie about it. You know, I didn't want this to happen. But I should also have made sure that we could reflect on, we can change our schedule. We can reprioritize against our most critical options and ultimately be confident about our team's long-term success. As a leader, be aware of the shadow that you're casting. So when you walk out of that frustrating meeting, or when a decision doesn't go your way, and also remember whenever your team experiences success, what is the behavior that you want to show, that you want your team to copy? Now, depending on the level of leadership that you find yourself in, you're going to find yourself involved in some level of strategy. At Citigroup, my role was split really kind of 70%, 30% between development and management. The management piece was really just taking lists of tasks, items to be delivered from the business analyst, and I would look at them, size them with the team, assign them to someone, and build the schedule. The most I thought about strategy was maybe looking at some opportunities, maybe some risks, but ultimately it was about task management and setting expectations. When I joined BDNI, that was a bit different. So I traveled to California, I met with the team for 3 weeks, I met with the product leads, with my own boss, I met with the engineering leadership, met with the CEO, and we talked about with the vision for Belfast. We talked about the vision for this next version of the product. The product is it's very simple. The product basically tells large enterprise customers what they have in terms of hardware and software. It gives them control over risks, opportunities to reconfigure your data center or look for vulnerabilities in software, etc. And the vision was quite simple, as we wanted to take this idea, this value that we had already proved in the world of business IT, and we wanted to apply it to other industries like healthcare, heavy industry, and ultimately IoT. So that meant the product had to scale, and the data model had to transform almost entirely. It was so static. And now my involvement with strategy was much more profound. I had to think about the timeline. So the business had a date by which they really needed this new version of the product available to be successful. I needed to think about the technology strategy. Were we going to rebuild or iterate on the version that we already had? What technologies would we use? How fast could I hire a team? And what skill sets would we be looking for in those people? What about the migration strategy for customers going from the old version to the new version? Were we going to be agile or go waterfall? Gone were the days of task management. Now the tasks needed to be discovered. We needed to prioritize them and figure out which ones were going to lead us to success. And on top of that, I had to grow and enable the team and develop that sense of innovation. And then we joined Flexera, and my role changed to Senior Director of Engineering. And talk about being promoted beyond your level of competence. Overnight, I found myself strategizing merely for survival. The business was asking for roadmaps I didn't even know existed. I was struggling to retain my team. Timelines were slipping, and I was pretty sure that my stakeholders were losing faith in my ability to deliver. And coming right back to the start of this talk, Art's words were still ringing in my ears. And it was the wake-up call I really needed. So I started to look around me. I started to look at the other engineering leaders in Flexera who were somehow being successful amidst this chaos. I started to ask, what are they doing that's seemingly enabling them to be in control? And I identified two things about myself. The first thing I discovered was that I was actually still just managing tasks. I was trying to size and de-risk everything before committing to it. The roadmaps I was developing were barely useful beyond 2 or 3 months. I just could not deal with any amount of uncertainty in my plans. Second thing I discovered was that I wasn't being creative enough about the order in which I was delivering. I was always thinking in series. Every feature, every capability, I was trying to deliver 100% of it before even thinking about the next thing. Strangely, my wife complains about the same thing. I tend to eat in a very orderly way around the plate, and it really annoys her. And in the world of a fast-moving technology company, thinking in series just does not work. So I started to challenge my team to think differently about the scope of what we were doing. Could we start to deliver just enough of the code, just enough of the value to try and meet our outcomes, and take everything else and put it in the parking lot? I also started to rethink about the way that we were sizing our work. So instead of thinking about how many days was it going to take us to do this, we started to use the concept of similarly sized items in a much more lean fashion. Now, we still slipped a few dates for sure, but the way in which we were able to deliver was transformed, and we've been improving on that ever since. Last year, I read a book by a guy called Chris Hurst. It's called No BS Leadership, and he doesn't use the acronym in the title. It completely transformed my understanding of what leadership actually was. Chris completely debunks the idea of highly detailed business strategies, and he redefines leadership. He talks leadership about being quite simply the art of getting stuff done. In the book, he discusses Colin Powell's approach to risk-taking. For you people who are much younger than me, Colin Powell was a 4-star ranked general in the US military, and he served as Secretary of State to George W. Bush. And Powell stated that he always wanted between 40 to 70% certainty about any decision. This blew my mind. 40%. I can't choose my socks with as little certainty as that. 40%, anything less than 40%, and Colin Powell argued that you were shooting from your hip. But then the 70% thing confused me as well. Powell said he never wanted more than 70% certainty, because if it was more than 70% certain, then someone on a much lower pay grade than him could have been making that decision. And he argues that it's intuition that really distinguishes great leaders from everyone else. And this book took a great weight off my shoulders. It completely freed me in my thinking. And I found myself in the last number of years being able to take much bigger bets, setting much more dramatic and ambitious goals with my teams as a result of it. Earlier this year, I was involved in a conversation with a number of my PMs across 2 products. One product was mine and one was not. And I was worried that one of our key corporate strategies was being hindered by the fact that these 2 products were cannibalizing each other's market. To me, the solve was obvious. There was a key feature that we needed to deprecate in one of the products. But I was also very aware that this was not the first time it had been proposed, and it was quite controversial. So I talked to my boss about it. I found one of our key salespeople, and I talked to them about it. I met with the strategy team, and I talked to them about it. And then one Friday afternoon, I got no fewer than 5 PMs on a call, and I laid out my thinking as to why this was a problem. And by the end of the call, we'd come to a plan of record that we would deprecate that feature in the product that I didn't own. Nothing in that was to do with engineering. So why was I involved? Well, at Flexera, if you're a leader, you're encouraged not to stay within your area of specialism. You're to understand the business, understand our goals, understand our strategic initiatives, and if you see something that's not right, then you're encouraged to take action and initiate change. Ultimately, it's about making our customers successful. And as an engineering leader, you're never going to have enough time. Your PM is going to have a list of features the length of your arm, which all need to be delivered in the next sprint with no room for anything else. Support are going to have a set of one bug that needs to be fixed tomorrow. Sales are demanding a new feature so that they can close that one big deal before the end of the quarter. Services need more documentation. The solution engineers need another API. SRE are complaining about excessive IOPS. Architecture are encouraging you to adopt a new API design. The engineers have a list of tech debt they want to clear up. And the CEO just wants to know when it's all going to be done. And every single person thinks that their stuff is the most important thing for engineering to be working on next. As a leader, it is not my job to protect my teams from this bombardment. But it is my role to make sure that they understand our goals, understand our objectives, understand our customers, so that they can assess each stakeholder's needs and ultimately decide what is important. I told one of my team members this week, we were just like spinning plates. And I said to them, look, some of these plates are going to fall. We're not going to be able to stop it. Let's just make sure it's not the fine china. So knowing which issues are going to kill you and which issues are just going to cause you temporary pain is a key responsibility of you as a leader. And it's going to come from knowing your company or your organization, know your customers, know your goals, and know your technology. I was really proud of one of my teams just this week. It was Wednesday. We were onboarding a new customer to one of our platforms, and their stream was so slow. It was going to take 11 days for them to get on board, and the solution engineer was quite rightly just going to call it quits and go with a different product, which would have been a disaster in terms of PR for my organization. So we had a decision to make. What do? Do we stop development and all these features that are committed? Do we let the POC fail and just take the PR hit? The team found option C. They found a way to prioritize the stream for this one customer. And bam, that customer's data went in. Now, there's still a problem. We need to figure out why that stream wasn't working right. It's going to happen again at some point. But the team found a way to de-escalate this crisis, make the POC successful, and allow us to continue developing on our roadmap. Now, I've developed a love for these situations, not because I enjoy the pressure from stakeholders, but because I've come to realize that my teams are going to be able to deliver. And nothing gives me more pride than seeing them solve these types of problems. So leadership is not for everyone. You have to have an ability to relate to people in a genuine way, have passion for your organization's customers and the mission, and to be authentic even whenever you're about to have a difficult conversation. And you need to understand how to build technology for resilience, robustness, maintainability, and security, and be ready to protect your organization from bad technology decisions. So let me leave you with this. If you are considering going into a technology role, the path isn't always clear. A leadership role, the path isn't always clear. Sometimes it feels a bit hazy, and you might feel like you're just fumbling away in the dark. When I started my journey into leadership, the first real determined step I took was to leave Oracle, a job I was good at, and a team that I loved, to go and join BitNet. And I got made redundant. BitNet was my opportunity to develop into a role where I would be in leadership. It wasn't exactly the dream journey that I anticipated. But without that step, I wouldn't have ended up at City, and I wouldn't have ended up at BDNI, and I wouldn't have ended up at Flexera. So I want to encourage you that even if the way doesn't look terribly clear right now, I'd encourage you to persevere, be ambitious, and whenever you look back on your path in the years to come, the path is going to look very clear indeed. Thank you very much.
Hang on. Is Phil coming over here? Or am I going over to Phil? Okay. So I'm being professional. Do sit down. Yes, thank you for that. Very interesting. Right, we have a few questions here from the audience.
Okay, great. Hit me.
First of all, somebody just wanted to say it was a great talk. They really enjoyed the honesty and transparency there. So thank you for opening your soul.
I can't do it any other way.
First, most popular question here. Did you get overwhelmed with the task ahead at Flexera at certain stages? And if so, how did you cope with it?
That's an easy question to answer, yes. There were many occasions when I felt overwhelmed, and one thing I would say is that, particularly that conversation with Art, it transformed my career at Flexera. It was very, very challenging. I left that one-to-one conversation within 7 minutes of it starting. It was scheduled for half an hour, and so I was totally overwhelmed. But Art and I have a fantastic relationship, so he didn't just hit me between the eyes and then leave me to it. We've developed that relationship since, and I talk to him all the time. He mentors me, he guides me through these decisions. But other things I would do is I have mentors outside Flexera. There are some fantastic leaders here in Belfast who I consider mentors. They may not know that, but I'm watching them and I'm learning from them, and I talk to them and I watch what they're doing. But yes, I was totally overwhelmed. And I wouldn't say that there was necessarily anything that I can recommend.
So,
a path.
Look outwards rather than inwards.
It's just look what's going on, look what other people are doing, and more than anything else, be resilient. Sometimes you're just going to have to figure it out, and just sticking at it and try again, fail again. Okay, what didn't work? Why didn't it not work? Try something different.
Another interesting one down here. Does the context switching between product and engineering tasks not mean you're working suboptimally?
I guess it does. My job is I would say my job is suboptimal all the time. I'm context switching every half an hour, I would say, and I think that's something if you're considering going into a leadership role, especially at a more senior level, being able to context switch is important. It's different than being an engineer, though. I have a team of 140 people. And so whenever I'm context switching, I think the important thing is knowing when you need to delegate. So if I say to someone, okay, I'll take that project on, if I try and do that myself, it will not get done because my time is suboptimal. So what I do is if I'm given a project and I accept that project, the first thing I do is, well, who do I have? Which of my teams, which of my people do I trust to get that done for me? So it depends what level you're at. Product and engineering, I think if it's being done right, your product teams should be, you should have your product managers embedded with your engineers, your UX folk, your architects should all be part of that delivery team. So I think it's more important that their time is optimal rather than mine.
Yeah. Okay, another one here. Somebody here is in a role similar to yourself, and possibly is asking here for actual advice at this stage. When people leave, what's your thoughts on key tips for dusting yourself off and getting back on with it?
I still remember the first person that left our team was one of the support engineers, and it knocked me for 6. And I'm not sure if it's just me or if other site leaders who have done this can empathize with this, but we built our team to about 17, 20 people before the first person resigned. And I still remember it was as if they'd divorced me. I was angry. I didn't understand why does someone want to leave my team? I took it really personally. Part of it is just you get used to it. You start to realize that, look, these are people making.
Hard-hearted, do you?
They're making the right decisions for their careers. There's a reason, and the important thing for me is that I try to understand: is there something we could have done better? Let's fix that for the next person, so we don't make that mistake again. Let's always improve. I don't take it personally anymore. You know, I think that the last few people that have left, we've made a conscious effort to celebrate the fact that they're going on to roles that they're excited about, that they're going to excel in. So I try and look at it very positively. I think the important thing is identify if you're doing something wrong. Yeah. Is there a reason why people are leaving? Yeah. And if there is, go and fix that thing.
I mean, do you actually do exit interviews, or do you try and catch it before that?
We do both. You know, so I meet one-to-one with every one of my team members once a week. All of my managers do the same with their teams. It's mandated by our CEO. So if there's an issue, typically we know about it. You know, I think that you want to be having those conversations so that issues don't come as a surprise. So you try and get ahead of it, and then we do exit interviews as well, so that we know if someone's leaving, why are they leaving, and is there something that we should be doing better.
Okay, well, I think we're just about at time there, so thank you
very much.
Very much for that. We could have gone on a bit longer there probably, but we'll call it at that. So next on track 1, we have a couple of talks back-to-back from Sensata, our platinum sponsors. So they'll be talking about a couple of different aspects of working with embedded systems, which is something I've always found quite interesting, and is how quite a lot of kids are starting to get into coding these days, what with the Raspberry Pis and everything. And on track 2, I think it's Matt Coulter from Liberty talking about serverless. So we'll hand over to the Sensata speakers.
Hi, and today, my name is Lucy, and today I'm going to talk about keeping trucks on the road through data analysis. So, first things a little bit about me. So I'm a data analyst at Sensata Technologies, and I've been with them nearly 1 year. So I'm also in my final year of my master's doing data science at University of Georgetown. So I have a keen interest in looking at patterns that evolve using data. And also, since I was a little girl, I always wanted to be a truck driver, as I was obsessed with them. So working at Sensata has helped meet both these passions. Not quite the truck driving though. I'm going to speak today on a brief introduction to exploratory data analysis with Python, and we'll use a machine learning model to try and predict the next instance of data. So firstly, just a little bit about Smart and Connected. So it's a service of Sensata Technologies. As it says in the slides, they manufacture sensors which provide actionable insights for the driver and company. So similar to the tire pressure in your car. If your car is modern enough, a little light will come on your dashboard, which tells you that the pressure in your tire is low. So similar to this, Sensata also provide actionable insights to both the driver and a fleet manager, educating them and warning them on the health of their tires. So the next slide, we can see an example of some of the data that we collect. So through the sensors and telematic devices, this is a list of the data. On the left, there's an image of the valve-mounted sensor. And just below that, you can see the outline of a truck and all its wheel positions. So for the data example that I'm going to show later on with the machine learning model, we're going to use wheel position RRI, which is the third axle on the truck. So the data is collected from a telematics device, which has been installed on the truck. This is then all pushed to a centralized data store on Azure Cloud. We then use PostgreSQL database running on a distributed and highly scalable infrastructure that allows us to grow our capacity of trucks and devices over time. The data is then fed into Databricks using Spark data pipelines, which is transformed to make it analyzable and ingestible for a machine learning model. So, tire pressure prediction. So, for the test vehicle we will be looking at, the data is transmitted to the cloud every 1 minute per wheel axle, meaning that we receive data from a signal wheel position every 7 minutes. It's important to note, although there is just one vehicle, we have 10 separate wheels to look at. So thankfully for this case study, we'll just focus on one. So what are we looking for? The sensor is built with warnings, which are a certain threshold set by the fleet. However, the goal of this, what we want to do, is basically predict what the wheel pressure will be in 1 day or week's time. There's no use having real-time data We want, because then the accident's already happened, or the incident or the breakdown's already happened. We want to know what it'll be in 1 day or 1 week's time. So if we can see that a certain vehicle is travelling on a particular route every day, and this is affecting the pressure, a fleet manager will be able to prepare for a tyre change before an incident occurs, reducing costs in the likelihood of breakdown services, downtime, and potential accidents. So data pre-processing. So usually in data science or data analytics, the pre-processing or data cleansing is the lengthiest, Thankfully, as this data is used every day, we have a function in place that deals with the default values. So default values are whenever the sensor hasn't been able to pick up a certain signal, we get the likes of a default value being like 9999. Or missing values or changing different metrics, the likes of pressure from mbar to psi and date from Unix timestamp to date time, that's all dealt with in the function. So in the images, we can also see the first 5 rows and the shape of the data, which is 32 columns and just over 178,000 rows. So exploratory data analysis is just data visualizations to draw meaningful patterns and insights. So some of the best libraries for visualizations and explorations in Python are pandas, matplotlib, ggplot, and seaborn. So in the top left, we have used the pandas describe method. This gives us descriptive statistics, like the mean, standard deviation, and max. So it's a really easy and quick way to see outliers, any outliers. Top right, we can see the relationship between different variables. So we can see that there's a positive correlation between the temperature and pressure, which makes sense given the principles behind the ideal gas laws. Bottom right, we see a pie chart showing the no alerts status and low alert status. So low alerts make up just under 5% of the total data for this use case. The low alert strategy is edge processing built into the hub, and given a certain threshold, it'll flag an alert when the pressure of the tyre is not what it should be given the temperature of the tyre to an X percentage below. The bottom left, we can see the route our test vehicle in the US is travelling. So the circle indicates areas of high alerts and of high altitude. As you can see, more areas appear to have a large circle, which represents high altitude. So you can see there's an area just on the right-hand side of the map. I think it's near New York, so it's a small circle, but there's alerts there. But as you can see, most of the circles are big, so this would give some sort of pattern that areas of high altitude cause more low alerts, and this is what we want our model to learn. So, using PyPlot, we can create a plot with 4 different subplots showing 5 months of data for each variable. So note how the sensors were installed on new tyres, and after about 4 months worth of data, the very bottom plot at the top, we can begin to see low pressure alerts. And at the bottom, with the stats model library, we can use the add filler function, which calculates the Dickey filler test. So this gives us our p-value, which we can see is less than 0.05. So we reject the null hypothesis. So this means that the data is stationary. Now, stationary time series data is one whose statistical properties, such as the mean and variance, are all constant over time. This makes it a lot easier to model. So from this graph, we can also see how volatile the pressure data is. So why LSTM? So LSTM, or long-term short memory, is a type of recurrent neural network. So it's designed to handle sequence dependence. So what's unique about the LSTM network is that it learns from the information that's stored in the long-term memory and what to get rid of, making it more effective for time series problems. So this is really useful because it will discriminate against older iterations to ensure that it is optimizing for newer, more up-to-date data, but it won't lose the longer-term context. So I developed the LSTM network in Python using Keras deep learning library. So normally LSTMs are used on very large data sets. The one that we're using is not, it's about 23,000 rows, so it's not huge, so just bear that in mind. So using a correlation matrix, I drop the correlated features. So this is done using pandas, it's very easy. You'll see the second image on the right. So I then use one-hot encoding, which allows the representation of categorical data by giving it a number instead. So most machine learning algorithms don't work with categorical data directly. And then I also normalize the features, which gives the numeric value to a common scale between 0 to 1 without distorting the difference. So there's a video here just of my LSTM model and the results that we get. Now bear in mind, I made a mistake. I meant to refer to data robot and not Databricks. We're now going to see the LSTM model in action.
So here we can see the data has been separated into training and test section, where training is the first 4 months and test is the last month. So normally with time series models, seasonality trends would be taken into consideration. But because there's only 5 months worth of data, seasonality trends are ignored. So we'll firstly define the LSTM model with 30 neurons in the hidden layer and 1 neuron in the output layer for predicting the tire pressure. So the input shape will be one time step with 15 features. So we will use mean absolute error loss function to measure the success of the model. So mean absolute error measures the average magnitude of the errors in a set or predictions. So RMSE in a way donates sort of the sum of the distance of individual predicted data points against the actual data points. So the model will be fit for 50 epochs firstly and a batch size of 90. So the epoch is the number of passes of the entire training data set the machine learning algorithm will complete. And the batch size is the number of examples from the training set used in the estimate of the error gradient. So as we run this, we can see the train and test loss during training. What we don't want to see is the test loss dropping below training, as this will indicate the model's overfitting. So let's look at the graph. So we can see it's getting there. It's taking quite a lot of epochs in order to come down closer to the training result. What we could do is increase the epochs. Let's have a look at the RMSE. So it's 5.33, so it's not too bad. Right, we'll try again. I'm going to actually increase the neurons to 50 and decrease the batch size. Let's see if that works. This will just take a little bit of time, but hopefully we will be able to see the test line is slightly closer to the training line. And we ideally want to have an RMSE sort of below 5. The RMSE is completely relative to your own data set, so you just need to find something to compare it with, which I will show in a minute. Okay, so you can see that it is closer now. It is very chunky. Now, given that this is a smaller data set, the LSTM model does work better on bigger data sets. So I believe if we did have more data, that maybe would become more straight fit. Let's just see what the RMSE is. Okay, the RMSE is 3.847, so that's better. So like I said, you're best to compare the RMSE with other models. So what I've done is use Databricks, which is sort of a company that allows you to basically upload your training set, and then you put in what your Y outcome is, what your Y feature is, pardon me, and then it'll run a load of different algorithms to see what the best metric is. So this is the metric chosen as RMSE. And then now I don't have the subscription for the time series, so what I'm just seeing is regression models here. So as you can see, now it recommended the random forest regressor, so it's giving me 3.054. Extreme gradient boosted tree regressor 3.128. So all in all, 3.847 is pretty decent RMSE first time round. Now, there are a lot of other things that we can do to improve this, which we'll talk about in the next slide.
Okay, so I achieved a pretty decent RMSE, but there's a few things to consider. That was just for the next 7 minutes, whereas the goal is to have the next day or the next week. So it would require a lot more data. But it will also help with them improve the LSTM accuracies as well. So there's a few things I'm going to do to work on this model. I'm going to use a weather API to give me more data, especially the likes of outside air temperature, humidity, wind speed, cloud cover, which I all think would contribute to how a tire reacts in different weather conditions. Also additional vehicle data, the likes of what the tyre manufacturer is, the year of the tyre, also the likes of the truck year, the truck manufacturer, maybe the driver ID. So if we can sort of have a driver ID attached to a certain vehicle, maybe how the driver drives would influence the tyre wear as well, and tyre pressure from that, and also additional sensors for other metrics, the likes of having a weight and a brake sensor as well. And other insights which we can predict from the model would be the likes of tyre mileage and tyre depth. But still a work in progress. But thank you so much for listening.
Hello, my name is Lucas Giuliano. I'm an embedded software engineer at Sensata Technologies. And today I'd like to talk to you about virtualization for embedded systems. And more specifically, how it's become more common in the embedded world. So for today's agenda, I'd like to touch bases on what is a container, issues with containers using namespaces, specific issues related to embedded systems, solution that we have for embedded system, and the benefit of those solutions. And at the end, I would like to give a quick demo of a virtualized system running on a Raspberry Pi. So to start with, we need to understand what containers are. Containers are a solution to a problem of deploying software in different computing systems or different computing environments. This is accomplished by creating a package which bundles the application binaries, libraries necessary, all dependencies, configuration files, and so on. And the type of container that I'm talking about is the one that basically create kernel namespaces, which are used to provide isolated workspaces. So every set of container is a set of namespaces. So every container then that you creates an isolated workspace that has a limited access to just its own namespace. That means then that the kernel then is shared among those different namespaces. And actually that's where the problem comes. So creating containers based on namespaces poses a problem. It means that the kernel is shared among all those containers, and to access the kernel then there's a syscall API that is very big and very difficult to secure. It makes it easy for applications running on containers to make use of the access to the kernel to exploit it and run malicious software and take control of the rest of the system. This is a well-known problem actually, and a lot of guidelines to prevent this problem are already in place. Hardware virtualization is the one always recommended. And in fact, very often we will find hardware virtualization coupled with containers. In the embedded world, we have even more specific problems when using namespaces as containers. One of them is mixed criticality. Very often in embedded systems, we have mixed criticalities, or different applications that have special needs and different criticalities on its own. So for example, the infotainment system on your car may be running in a different criticality than some other system that is able to connect to the COM bus. And you don't want the infotainment system crashing and taking it together another system that connects to the COM bus, because those COM bus systems are essentially connected to a lot of other important and critical systems of the vehicle. Or even worse, something that has actually happened before when hackers enter through the infotainment system of a car, and through that they were able to connect to a different firmware that had access to more critical lines in the car, and were able to then mess with the rear view camera of a car while a driver was backing up. That caused a crash, of course. There are other examples that don't involve infotainment systems. If we go to drones, for instance, we can have a drone that typically will stream video through a mobile device, but also you have a navigation system there. And we don't want the streaming of a video crashing and taking it together, the navigation system, because of course, if the video is not working, we still want the drone to land safely. And another issue is the resource utilization protection problem. Because all containers are accessing directly the kernel, it's very hard to prevent different containers to overuse the CPU or memory, making it very easy for malicious software running on specific containers to access the kernel and just use all the CPU, all the memory, and crash the whole system. We also have the problem of real-time support that is not supported when using containers. Because, again, we are using the same kernel space, we are only able to then use a real-time operating system if that kernel supports that. But the reality is that sometimes we do want a real-time operating system for some applications, but sometimes we don't need that. And let alone use an RTOS, that is really difficult when using namespaces. So the solution for the embedded systems, much like other systems, is to use virtualization. This is called hardware virtualization type 1 or bare metal virtualization. It basically is an abstraction software that sits on top of microprocessors or the SoC and abstracts the hardware and software, making it possible for us to run different OSs and completely separate the resources they are capable of accessing. This really restricts the access to resource of each individual VM or virtual machines, and that brings a lot of features that we are going to look at now. And so by using the hypervisor, and that's what's called a layer of software that we put on top of the microprocessor, we'll have isolation and security. This means that now it's much more difficult to gain access of another container that is located in a different VM. If we have our infotainment system running on a VM that gets hacked, it will be very difficult for a hacker to go from there to accessing another firmware running in a different VM. We can now support mixed criticality. Now we can have different scheduling running in different VMs. We can have a Linux kernel running in one VM and even an RTOS running in another VM with completely different criticalities. We can now deploy separately all the units. We can deploy those VMs independently of each other and no longer need to worry about how they interact with each other. We have more resilience now. So if one VM crashes, the other one will still remain there working perfectly. We can vary our boot times. Now, because we are in different VMs, one VM can boot faster than the other according to their criticality. We can also virtualize coprocessors, not only the microprocessor, but let's say we have GPUs connected to your hardware. We can also virtualize that. And so now I'd like to show you a hypervisor running on a Raspberry Pi. This video was recorded yesterday, and I will talk you through it. So basically what I have here is a Raspberry Pi connected to the UART interface. And the reason why I have that is because I want to show the boot up process. And more specifically, I want to show that we are not booting up a typical Linux system, but rather we are booting up a hypervisor. So I will go up there and I will show you at the start of the boot up that we are actually booting up something called Minus, and that's a hypervisor project, open source. And straight after that, I'll show you also there that we are then creating a VM, and that VM then contains the Raspberry. The reason why I'm using Linux is just for the purpose of this demonstration, but I could be using an RTOS or anything else. But really, this just makes it easy for us to run the first VM as a Linux-based VM, and from there we can generate other VMs, and that's what I'm going to do. So I'm going to check now here the IP address of that Raspberry Pi and start accessing it in 3 different windows. The reason why I'm doing that is because I want to have one window to create the VMs, and the other 2 windows I will use to log into them. So there I logged into the first Raspberry Pi section, and then we're going there to the 3rd SSH session to the Raspberry Pi. And once I finish that, then we're going to use a helper script that comes with the Minus project to create those 2 VMs. So there you go. This is the help script that I'm going to run. I'm going to, for the purpose of this demonstration, start with a 32-bit image, and then later a 64-bit image. And then when we log into those machines, we'll be able to see that they're actually executing different images. And so the way we're going to log into it is because Minus routes the output of the console to /dev/pts/one number there, and this is and we start with 3. So we log there, and we can see that the version of the distribution that we are using there is 32-bit, and now we're going to create a second VM, and that VM now is going to be a 64-bit, and so now we can log into that, and we should see that the version now is different than the other VM. So we have then 2 VMs running. One VM is a 64-bit and the other a 32-bit. So now I'm going to do something very interesting. It's something that we talked before here, which is the fact that overloading one VM will not affect the other one. So basically I'm creating 4 for loops there that will overload the CPU. Hopefully will be above 80% of CPU usage, and we will then compare the usage of the CPU on the 64-bit machine to the 32-bit machine, and as we can see there, we are going to go over 80%. And now we can check the other VM, and we'll see that nothing has changed there, so the CPU usage is pretty much the same. So there you have it. It's a very brief demo and explaining the usage of virtual machines in embedded systems and how that can help us protect our different environments there. Well, thank you so much for your time.
Fantastic. Now we have a number of sponsored promos that we would like to share with you. They are from Rapid7, Signified, Flexera, Allstate, Instill, and last but not least, Sensata.
Hi everyone, I'm Phil Wilkinson, Senior Director of Engineering and Belfast Site Leader for Flexera. Flexera are proud to be sponsoring the Northern Ireland Developer Conference once again in 2020, albeit this year it's a little bit different. But we're looking forward to celebrating the local talent that this community has to offer, and as we do every year, we're looking forward to learning some new things from our peers and our friends in this community. We hope you enjoy the conference.
At Rapid7,
we are all the keepers of the culture.
And it's all of our responsibility
to embrace and live it
every single day.
Together, we will continue to scale our amazing culture
into the future through our willingness
to understand and internalize it.
Together, we will build a company.
Not just that changes the security landscape,
but allows you to build a remarkable career
alongside some equally remarkable people.
One of the things that attracted me to Signified was the idea of small teams. So 4 to 5 people on a team with a principal developer in each team. Everyone's really approachable, really friendly. And the fact that we're a fresh team in Belfast, everyone's kind of learning together. It's one of the most attractive Java opportunities in Belfast at the minute.
Hi, I'm Charlene Hughes. I work for Sincella Technologies and I manage the project managers for Smart and Connected division. Smart and Connected runs like a startup business, which means that we are very much in the early stages of developing new technologies. And the technologies we develop are for heavy vehicles and trailers. So we work really closely with a large majority of the OEMs across the world and also with large fleets across the world. My team, work with the engineering department on all the new exciting stuff, right through from a piece of hardware development, right up to software, and now even better, the team are working on a full IoT full stack. They're looking at web portals, phone app developments, and this is all geared towards these customers, these OEMs, these fleets. The good thing about being a project manager for S&C is that you get to see something on paper right through to the end solution. You get to see a piece of hardware, you get to see the full solution going onto a vehicle, and what makes it even more exciting is you get to work closely with those customers who absolutely love the technology. If you want to learn more about Sincella and what we do, and even the project management team, please feel free to reach out at any time. We're always looking for new talent to come and join our team because we're forever expanding and growing.
Some fantastic videos going on there. It's great to see a little insight into the culture and a little bit into what some companies are doing. So we've got a few minutes before we go to the next talk.
So guess what happens now?
I get to interview Mark.
We're gonna blether again.
At least I think we're good at doing that.
Yeah. Well, once we get going, we're pretty hard to stop.
That's absolutely true. So Mark, what projects are you doing at the moment?
Oh, no, there's questions. Right. I'm doing one project at the moment for the UK census. I'm doing that for a company called Total Mobile, who you may have come across there up in the docks there. But they have a product which basically is for field workers and the like to go out with tablets or mobile devices, collect information, and bring that information back to the office. Yeah. So it's a very flexible product. You can use it in all sorts of situations. Healthcare is quite a common one, but in this particular case, they are going to be using it in the UK census. That includes Northern Ireland and Scotland and England and Wales, yes. So yeah, all four of them.
Wales does exist.
But they're using that product to go out, not for the people who are filling it online on the websites, but for all this, all the several thousand staff that have to go out and knock on people's doors and say, have you filled in your census? Why haven't you filled in your census? And they go out to sort of caravan parks and all that sort of thing to go and do the non-standard people. Yeah. So what I've been working on for the past wee while for them is taking that product, which is kind of mostly and historically been used for smaller companies, SMEs and the like, and rebuilding parts of it and building new parts of it in a fully serverless way so that it can scale up to the size required without breaking everybody's bank.
That's always a good consideration, especially if you're talking about public money. So, that sounds really interesting.
Yes, so that's one of the things I'm working on at the moment.
I know you never stop, do you? Yes. Between taking over meetups and...
Yes, and I'm trying to get a couple of meetups going. Obviously, I'm a Microsoft Azure MVP, so I do a little bit of that's not quite so busy as it used to, because a lot of that was traveling around and going to do talks at places, but I'm actually taking COVID as an excuse to just sit back and relax and do very little of that sort of thing, apart from running the occasional conference.
I was wondering about that. It's like, I don't have enough to do. Let's run a conference this year. So much for relaxing. But that's absolutely fantastic. And I suppose what's coming up the rest of the day, we've only got a couple more talks left.
Yes, well, I know, without spoiling the surprise, I know we've got a bit of Azure coming up in the next talk here, so that's good.
That's what you're interested in.
We had some AWS earlier in the day, and I think there was at least a mention of Google Cloud floated past at one point.
Yes, I did see that.
All the big ones.
Yeah.
No Ali Cloud yet, I don't think, but
at least we already have one on open source as well, which was good. So yeah,
I'm big into serverless, and I'm pleased to see that the open source serverless products very much big as well.
Very much. I mean, you are seeing a much bigger uptake of open source, and it's just shifting away from that old-fashioned view of you can't make money from it, or it's not useful, or so it's good to see that moving on.
Yeah.
But I suppose it's time for our next talk. So
already?
Yeah, apparently so. So we managed to do that.
Get Mark to talking about himself. That'll fill time.
Absolutely.
Okay, tell us what's next.
What's next? I will have to check because I am not very good at remembering these things. So right. So who we have next is Claire Houston, and she's talking about AI in production. So this is going to be a really interesting talk, I think. So over to Claire.
Hi, thanks so much for the introduction. So as we said, I'm going to be talking to you guys today about build versus buy AI in production. So considering when you should want to buy and pay for your machine learning services, or when you should actually start from scratch and build your own. But first things first, I want to introduce to you guys to my friend Sally. So Sally owns a coffee shop. She has a pretty successful website, but she wants to take it to the next level. She wants to take it that step further. So she's thinking, and bingo. She has the perfect idea that she knows is going to take off and do great for her website. So next thing, she wants to get it out into the world and make sure that she's reaching as many people, as many customers as successfully as she can. So she introduces a chatbot and has a stranger come and chat to the chatbot. So the idea is that they will speak to it as if they were speaking to Sally herself, have a very natural conversation using speech that will then the chatbot will then feed the information into our website, into the great new product, and then have the information fed back out. So Sally's a pretty good idea of how she should do that. She should do it using machine learning. But the question is, Sally's wondering, does she need to go and get a master's in deep learning? Does she need to know everything there is to know about neural networks before she gets started? Or is there a more straightforward route? Could she go and pay for a machine learning service that would actually be able to provide a lot of these services for her? Can she go down that route? When should she go down that route? So that's what I'm looking to cover today. Whether you're deciding that if you ever want to touch machine learning, you have to start from scratch and build everything from the ground up, and everything has to be the best, most specific model to your exact problem. Or if you're in the opposite camp, if you're thinking that to do anything to do with machine learning, you're going to have to do all that and you just want to avoid it. You're a developer through and through, or you're just starting out, well, this is the talk to show you how you can get started in using AI in production. So today we're going to cover the difference between the two. You're going to learn how to know when to use one, when to use the other. We're going to cover some of the offerings from Azure Machine Learning, whether that's the machine learning services they have on offer, or learning how to build your own model on their platform. And finally, we're going to look at some machine learning coding examples. So as was said, my name is Claire Houston, and I'm a senior AI engineer at Kainos. I've been working in AI for about the last 3 years or so, working in the AI practice in Kainos for the past 2. And I work in natural language processing, so processing a lot of text documents with machine learning. I've done a lot of work with chatbots, and I've done work with productionization. And something that I think is important to remember when it comes to productionization, it isn't always that we've built a very specific model, got that up and running either by us or the customer's given us. Frequently, it is about using a machine learning service that is out there already, that we change, that we alter, that we implement into existing systems, and then put that into production. And that frequently is exactly what the customer wants, and they get to the value so much quicker. So I think that's important to keep in mind whenever you're watching this presentation. So what does it mean to build a model, and what do I mean whenever I say a machine learning service? Because I've said that word a lot. Well, whenever I'm talking about building your own model, I'm saying whenever you have to gather all the data yourself, you process it in some way, and then you train your algorithm to make a machine learning model. But you know you can't just do that once. You have to gather a bunch of machine learning models and train. There's a reason there's a circle going round and round and round. It takes a wee bit of time. Then whenever you're happy with your model, you have to deploy it. That'll take some setup, and you have to figure out the best way to do it. Finally, you have to make sure that you're continuing to monitor and manage your model to make sure that it remains providing use and value to your customers. As if you don't keep up, the model could quite quickly come out of date. For instance, if we're talking about Sally in our coffee shop, what happens if they're talking about this brand new coffee that's come out, or this brand new thing from Starbucks, like a macchiato or a macchi latte frappuccino? That needs to then be taken into consideration whenever you're talking about your model. So what are some of the features that you want to consider whenever you're talking about building your own model? Well, you need to think about the skills. You need the skills of a data scientist, an ops engineer, and a software engineer. Specifically, you need those data science skills to be able to prepare your data. You need your ops engineer skills to actually be able to deploy the model that your data science has prepared the data for, built the model for, then get deployed. And finally, you need the software engineering skills to actually be able to call to your model and be able to implement it into your existing system. As your model sitting on somebody's laptop, or for that matter, sitting on the cloud, isn't very useful by itself. It needs to be integrated. Something that's important to consider whenever we're talking about machine learning is cost. For instance, you need to pay for the cost of hosting the data. You definitely need to pay for the cost of training the data, training the model, unless you want to sit with your laptop for about 8 hours training it, and only to find that the model is pretty much useless when you get to the end. Totally hasn't happened to me far too many times. So you want to train in the right size compute. And then finally, you need to pay to deploy your model to make sure that whether you want it to be always available, allowing your customers to always access it, or if you're happy to do batch processing. That all adds up. All of that is on you to manage whenever it's your model. Data gathering is required whenever it comes to building your own model, as you need to feed in the data. That is what your model is made of. And it's important to remember that it has to be of a good value. It has to be, say if you're doing supervised learning, so you give it data and you want it to pick a specific label, all of the data that you're feeding in needs to be labeled. It can't just be raw. Flexibility whenever you're building your own model is very high, which is great because you're building it for your specific purposes, so it's always going to be able to do what you want it to do, provided all the other caveats are fulfilled, of course. But it does mean that it is very specific to you and your needs. Model maintenance, which I touched on before, is of course required. You need to always make sure it remains up to date with your customers and it remains useful to them. So let's look at the other side of the spectrum, machine learning services. So these are pre-trained models that exist up in the cloud that the likes of Microsoft or AWS have designed, built, and are sitting there ready to go. They cover services such as language translation, translating speech to text, text to speech, vision custom classification, image classification, and many more things beyond. But it isn't an infinite list. The models have to exist up there. And they're very easy to access. You only need developer skills to do so, seeing as it's a simple API call to be able to implement it into your system. And we'll see some of these later on. So what are the features you need to consider whenever you're thinking about buying an ML service? Well, as I mentioned, the list of required skill set has gone down from 3 to 1. You simply need to be able to make that API call to actually implement it into your system, and a few bits of authentication. That's quite a straightforward process. The cost is an interesting one, as it will entirely depend on the machine learning service that you actually use. So are you asking it to translate a simple sentence into a different language? Realistically, that isn't going to be too dear, but if you're trying to stream a video and requiring image classification the whole way through, that is going to rack up costs quite quickly. So make sure to check those out before you invest too heavily in those services. Data gathering as a feature isn't required, seeing as these are pre-trained models, so they're already up there. All you have to do is feed it the data that you want to be classified or examined or information extracted from. Flexibility is low in comparison to building your own models, seeing as there is a finite number of services. That number is growing, but frequently they're trying to suit a maximum audience. They aren't trying to figure out your exact needs for your very niche problem. Important to remember. And finally, model maintenance isn't required in the sense that you aren't responsible for the model and you don't have to continuously feed it new information. But on the other hand, it does mean because you're not responsible for the model that you actually have to make sure that if it suddenly stops doing what your customers want, oops, you have to maybe write a very nice email to the likes of Microsoft asking them to fix it. So there are 3 important questions that I always ask myself whenever I have a new problem that I know can be solved with machine learning. And I want to differentiate between should I build my own model or should I go and pay for a service? They are, is it a solved problem? Do I have access to the data? And will I get good results? So first things first, is there a solution already out there that I could pay for and immediately get value from? If that's the case, it's a no-brainer, pay for it. Don't start and try and come up with your own invention. Trust me, you're a good few years behind an existing service. It's already been done. That's only going to get better and you're only going to be playing catch up. Never mind the amount of time, effort and money you'd have to spend and pour into it trying to get it up and running. You aren't Google. It makes much more sense to actually pay for that service and get running with the thing that you wanted to do, the outcome that you want to have overall. Secondly, do you have access to the data? And I don't mean do you have access to a lot of data that's just kind of sitting there in a kind of useless fashion. Do you have the data that you need to solve your problem? Can you sort it into a nice fashion? If not, it's going to require some more processing before you're able to actually think about machine learning. With no data, you don't have a model. Finally, will I get good results? Now I know this sounds a bit like I'm putting the cart before the horse, but bear with. Essentially what I mean by that is there's a lot of time and effort that will go into if you're actually building a large-scale machine learning model, and it's important to do an initial check first of all. Do a proof of concept or a very small MVP to actually test will it work? Do you have the data you think you do? Will you be able to siphon it in? Will you be able to upscale to the model that is required for this purpose? All of which will save you a lot of heartache further down the road. So now we know the difference between buying and building. Let's look at some of the ways that we can do this. First things first, picking a platform. Now today I'm going to have a look at Azure, but it's important to remember that there are a number of different options out there. I sort of like to think of there being the big 3. There's Google Cloud, AWS, and Azure. All of these have machine learning offerings that are able to do quite similar things to varying degrees of accuracy. They're all very good, to be perfectly honest, but one may be slightly better than the other. But that isn't the be-all and end-all whenever it comes to the service. One may provide more for a similar cost, and one you might already have lots and lots and lots of stuff on that infrastructure. If every single other thing in your infrastructure is AWS, can't say I'd recommend going to Azure for that one tiny service. Stick with the one that makes the most sense for you. So as mentioned, today I'm going to be giving you coding examples using Azure. And for that you will need an Azure account and Azure subscription. Although a lot of the examples that I'm giving, particularly with machine learning services, they actually have a free tier associated with them, so you can actually sign up and you won't have to pay anything for them, which is pretty handy. Secondly, the examples that I'm showing are all written in Python, as that's the language well, it's my favorite language. But not all of the examples have to use Python. For example, the machine learning services, Node.js and C# are frequently options. So don't let that put you off actually getting started with machine learning. There is flexibility when it comes to machine learning, when it comes to the programming languages. So let's get started. Let's jump back to Sally and her problem, well, her solution for connecting her chatbot and getting that up and running. So first things first, she wants her customers to be able to speak to her chatbot and have a conversation with it. That means that the input speech has to be decoded into text. Speech recognition has to be performed. So what does that look like? Well, the incoming sentence needs to be said, hello. That will be converted into the wavelength that we see and is stored. That then gets processed by the computer into individual numbers, as a wavelength just won't understand that. Numbers, on the other hand, great. This set of numbers then gets processed by a neural network and then matched up to an existing word in a database. Now you might be wondering why machine learning has to get involved. It's individual numbers and it seems like a pretty straightforward matching process. But I'd ask for you all to cast your minds back to whenever Google Assistant and Siri first came out. The number of times I said hello Google to a blank screen that just blatantly ignored me was not funny. Suffice to say that whenever there's a lot of different ways that different people, different genders, different accents, different whatever, can say hello. Hell, there's even different ways that we can say hello about you. So it's important to remember that it isn't just a straightforward matching process. And that's wherever machine learning comes in and makes that process a lot more accurate. But all that's to say, Sally's wondering, should she build her own machine learning model to perform speech recognition? Well, is it a solved problem? As I've touched on, while they can be annoying, Alexa and Google Home do exist, so there is already solutions out there. Does she have access to the data? Well, she doesn't have lots and lots of speech recordings that she has translated for, so no. And will she be able to get good results? As was mentioned, it took a long time for Google and the like to actually be able to figure out accents, so it's going to take a similarly long time for her to get good results and a very large neural network required. So in this case, the best recommendation for Sally would be to buy. Here's an example of Azure speech to text recognition. I would like to buy a moderately expensive coffee from Ethiopia. I want enough to last me a month, and I drink 2 to 3 cups a day. So I hope you guys heard that. And essentially it's just an example of whenever you speak and the transcription being performed. You can see it was pretty accurate, maybe a couple of commas missed, but that was about the height of it. Overall, a pretty good service. So to actually do that, there were 4 key pieces of code implemented. The first, not necessarily code, but you had to create the resource on Azure, so following the speech. Next, you had to import the speech SDK after having installed it on your laptop. Then you set the configuration object and the actual speech recognition object using the configuration. So this is essentially the key to the speech and the region that you want to perform this operation in. And then finally, you call the recognition. Pretty simple process. Next up, we have natural language processing. So we have the input text, but we want to extract insight from it. We want to figure out what are the key words mentioned, what are the key phrases, what is the overall goal of what the person is trying to say. The computer isn't going to understand that right off the bat. This is where natural language processing come in. It is the avenue, it is kind of the department of converting human speak into understanding that computers can do. And it'll essentially break down your text into words, into meaning, into individual entities, and so on. That means that we can actually extract that information and perform an action on it in some way. Some task can then get performed. So if I say, hi, I would like to buy a moderately expensive cup of coffee from Ethiopia, I want enough to last me 1 month and I drink 2 to 3 cups a day. You have immediately figured out that I'm talking about coffee. I don't want to pay too much of it. I want it from a specific country. I drink 2 to 3 cups a day over the period of a month. All of that is instantaneous to you. But for a computer, that has to go through a certain amount of processing to pull out the required information. And that process is usually done through machine learning. So Sally is wondering, should she spend the time and dedication to actually building her own machine learning model to perform that action? Well, is there existing solutions available? The answer is yes. There's a lot of ones that are available for free, such as Spacey or NLTK, or there are offerings you can actually pay for from the likes of Azure or AWS. So, solved problem. Does she have the data to do it? Well, although Sally does have lots and lots of examples of customers coming with her for coffee queries, it isn't actually labeled. It's not, each of these isn't broken down into this word means coffee, this word means this word means this, and so on. So while she has the data in a raw format, it isn't labeled and therefore it isn't useful, so it would have to be processed. And finally, as you can tell, there was a few different things pulled out on the screen back there, such as language, key entities, and so on. Each of these requires a different machine learning model to actually be built for that specific purpose. Frequently, Sally may not need that information, but if she was building her own machine learning model, it would be up to her to maintain that and ensure its accuracy. So multiple models would need to be maintained, and that's an effort. So in conclusion, should she build her own natural language processing? Answer is probably better to buy it. So you can see here an example of Azure Text Analytics. And you can see a lot of text being going on the screen, but it's actually quite a simple process. Each of these is just individual method calls to perform a slightly different piece of text analytics. So you can see here it running. And the important information is extracted from it. So it knows about coffee, Ethiopia, and it actually provides Wikipedia links, for example. It knows that the language I'm speaking in is English, and it's pulled out other metrics as well. So, pretty useful. And you see here the key pieces of code are the resource that you have to generate, the text analytics, the relevant importation, the authentication that you have to perform to say, yes, I'm happy for you to actually use this resource on Azure, and the different methods that need to be called. All of these are from the one resource, which is pretty handy. Next, we have speech synthesis. So we want it to be a one-to-one conversation. We can't have the customer just talking to the chatbot. It needs to be able to chat back. And this is performed using text-to-voice or speech synthesis. So what does that process look like? Well, there's two key pieces of machine learning here. The first is whenever it's converting the written text into words that will actually be spoken. So if I say year 1843, doesn't sound quite right, does it? I know whenever I'm reading that text aloud that it's actually the year 1843, and there can be a number of cases of this. So there needs to be some processing to ensure it's being processed in the correct way. Next, it's converted into phonemes, which is essentially how words are pronounced phonetically. If you ever look up the definition of the word on Google, as I'm sure you've done like me to figure out how to spell things, you will see underneath random letters, and those are actually telling you how to pronounce that word. There's a bunch of people who can read it, and those are called phonemes. Then they're converted into sound, and the audio is played back. So that, lastly, being an example of machine learning. So Sally's wondering, should she build her own machine learning model for speech synthesis? Well, is it a solved problem? Jumping back to Alexa and Google Home, we know that it is. Does she have access to the data? Doesn't happen to have lots and lots of voice recordings lying around, so the answer is no. And finally, will she get good results? Well, like with the speech recordings, there have been lots and lots of work done to make the voice sound less robotic and less uncanny valley. So no, she probably will not get a good result without having a very large-scale model. So in conclusion, she should probably buy. And here we have an example of text-to-speech.
I'd recommend the southern weather if I'm not getting at least 3 bags. It's a good all-rounder and should please everyone.
So you can see there, it's not the most natural sounding voice, but it's not too shabby for a very quick setup. So you can see there that you actually use the same speech resource that you created before. You import the exact same speech SDK, you set up the same configuration, but instead of creating a speech recognizer, you create a speech synthesizer and then call it on the text that you wish to be spoken. For each of these examples that I've given previously, you can see that they're each very generic examples that a lot of people can find a lot of use cases for. And there are great reasons why you should buy and pay for those machine learning services. And hopefully, you can see through the coding examples that they're very easy to get started with. But let's look at something a bit different now. Sally is delighted. We've set her up with a brilliant chatbot that allows everybody to speak and talk to her process and get access to her brilliant new product that she came up with at the start of the presentation. But you may be wondering what that is. Well, it is a coffee selector. Sally wants each of her customers to speak to the chatbot and get a great recommendation back, just as they would if they were speaking to her. And to do this, she wants machine learning to provide the solution based on the data that she has been gathering for the past number of years. So if we consider the questions, is it a solved problem? Well, no. Nobody out there is doing this exact same thing as her, that she offers her perfect coffee recommendations. Does she have access to the data? Well, yes. She has been making these recommendations for years, and she has countless emails where customers gave her exact information and she made a recommendation back. Finally, will she get good results? Well, from the initial prototype that she's designed, things look pretty promising. She's checked a few of the resources, and so far, things look good. In this case, only one next step makes sense. It's time to build. So you may remember this diagram from the start, and it is Azure Machine Learning Studio, and essentially, which is Azure's platform to allow you to deploy your own built-from-scratch machine learning models. They allow you to store the data that you've prepared online in a safe place. You can then build and train your model either locally using their infrastructure, run it from your laptop onto the cloud, or run it entirely in notebooks on their hosted compute, whatever you want. So then you'll be able to train that on hosted compute of the right size and be able to speed things up or take longer if needs be. You'll then train. You'll be able to register and manage your models, so essentially compare them to figure out which is the best for your solution, and actually keep aware of that, something that can be quite tricky if everything's on your laptop. Then you'll build the image to allow you to deploy it, so installing all the installations you need, packaging it up, and then you'll be able to deploy it. So you'll be able to deploy it in the fashion that you need, you'll be able to monitor it, and make sure that it remains accurate for your customers overall. This process will take place again and again and again, and you do all of it on Azure. So here is an example of running an experiment. So as you can tell, this is off my laptop using Visual Studio Code, and I have set up just an example of the train and model Python files that I then run from my experiment script. Whenever I run this, it will then actually deploy onto my existing portal, and I'll be able to actually compare it against some of the previous experiments we've seen. So as you can see, I'm running it. And then almost immediately, it is actually running online. And you can see the comparison between the previous ones, whether that's how long they've run, the loss, the number of epochs they've run, whatever information you want to display, you can actually run it via the portal. And there's a couple of key pieces of code for doing this. You'll set up the temp workspace, so the actual machine learning workspace, the relevant imports, get them in. You'll actually be able to set up the workspace and all the installations. So that is for example, the experiment, the environment that you need to set up. You can specify all that. That'll then run on the hosted cloud Azure instance, the compute instance, and then you'll be able to run. It's all a pretty straightforward process. I'm not going to go into any detail around how to deploy it, as that could probably be a talk in its own right, but I encourage you, if you're interested in machine learning, specifically building your own models, to check out deploying them via this kind of example. So, brilliant, we did it. Sally has got her system. She has been able to create a chatbot that can speak to the user in natural text. They speak, the speech gets translated into text, and then the information gets extracted from it, passed to a machine learning service that's bespoke and will recommend the perfect coffee for them. This is then synthesized out, and it's complete. They'll be able to have a brilliant chat. So what are the key takeaways that I want you guys to take from this talk? Well, I want you to remember that no one shoe fits all. You can't just build every single model. You'll waste time, effort, and honestly, tears trying to do it that way. But you also shouldn't buy every resource either. There isn't specific enough resources out there, and it's important to be able to identify when you should buy and when you should build. You don't need to be a data scientist to start using machine learning in your software. You can simply be a software engineer to make those relevant API calls and get your products kickstarted with machine learning, and bring them in to make sure that you're making the most of these brilliant resources that are already out there. And finally, I want you to remember the 3 questions that I always say. Is it a solved problem? Do you have access to the data? And will it work? If you remember those 3 when you're trying to decide, should you build or should you buy, you'll be in great shape. So today we covered the difference between building and buying for machine learning, how to know when to build, when to buy, the Azure machine learning offerings we have, and that are available to everyone for both building your own and buying, and some machine learning coding examples. Thank you all so much for listening, and that is my Twitter and LinkedIn if you're interested in reaching me on either of those. Thanks very much.
What a fantastic talk. It's always good to hear what's going on in the world of AI and machine learning. And of course, we're going to go into a little Q&A session with Claire. She's going to kindly answer a few questions based on her talk. So here we go. Thanks. That was brilliant.
Thanks.
Really enjoyed that.
That's good. I don't know if everybody could hear, but like at the very end, there's just an incredibly small yappy dog outside. That was slightly concerning.
You'd be amazed at some of the noises we've been getting.
It's amazing. It's like it's honestly, I'm just happy to be out of the house. Like nice hearing people and hearing random dogs again. It's great.
I know. I think somebody mentioned that there's a lot of dogs around in this area for some reason. They're kind of a variety of them. But yes, so we've been getting some questions coming in. I'm just going to run through them very quickly with you.
Sure.
So, yeah, so you talked about data and how you need a wide variety and training your models as well. What have been the major challenges you've experienced in training your models?
So honestly, it can be a case where you think you have access to the data, and that's why I have the actually do a prototype, because you can think you have access to the data, and then when you actually feed in, you realize that it maybe doesn't cover all examples. You can come up with a model that's quite biased. If it has lots and lots of one class of examples, so lots of positives or lots of negatives, and you've only got a little bit of the other, it can unbalance your model. And so basically just making sure that you have the data that will actually do the job, and making sure it's classified in an appropriate way and labelled, instead of it just being sitting there randomly, which is still useful. You can still do analytics on it, but maybe it's not the right time for machine learning yet.
No, absolutely. Do you normally find that's quite a difficult process to get good quality data? Or?
It can be. It's sort of, different people are at different places when it comes to machine learning. As I was saying, you need data to have a model. But you can actually then set up people to start being able to scrape it, get it in the right place. So if we're given enough time, it can be grand. You can get it to that right place. Other times you can't, but it's something I definitely encourage everyone, if they're considering getting into machine learning, to check that they actually have the data that they think they have, and that it's in a good enough format to get started.
That's fantastic. Yeah, and I mean, data is what the world is driven on these days, absolutely.
100%.
Yeah, and just where you were talking about the early days of Google and Siri and so on, of course accents were a big blocker, and especially Northern Irish one and Scottish.
I really wasn't joking when I said it was the most annoying thing, because I had just got a new phone and turned on Google Assistant on it. I was so excited to start using it, and then I was talking to it and it just wouldn't work, and then my boyfriend at the time was like, okay Google, and then bingo, worked straight away. And it was my phone, and it was just from that point I was like, okay, that's done for a while. Took a couple of years to earn my trust back from there.
That's fantastic. Do you think that's now changed, or is there a lot of work?
I think we're seeing different problems. So those have been addressed, but we're seeing different ones come up. Like for instance, I'm not sure, I have a feeling many people from here might be on Twitter at the minute, if you saw the spotlight issue for the images. So essentially Twitter did this thing, so basically it's a different problem where they did this thing where they had an image and they automatically cropped it, so if you're on mobile, what the most interesting place would get shown. And for a lot of those examples, it was if there was a black and white person in the photo, it would focus on the white person consistently. Didn't mind where you put it. And there were other examples as well. There were some interesting crops and stuff, but it's another example of making sure that you are accounting for all kinds of problems that you can face, and making sure you have a wide range of people in the room helping to identify those problems. Because nobody writes an algorithm hoping it will be biased, but it's just a question to make sure you have enough kind of voices in the room to make sure you're getting enough input on it.
Yeah, absolutely. I mean, you've had some very public examples of where it's gone wrong, where they've pulled that training out to the public and it's gone wrong. Do you think in future that's something that can still be done? Can we trust human beings to help train?
I think so. I'd like to think so. It might be maybe more in a more controlled way. Maybe there should be more fail checks in there to make sure that what's being fed into it is appropriate. As there are plenty of exploitative features and processing. Maybe there just has to be a screening. Like if you're teaching a child, you don't generally say all of that stuff to it. So maybe you should treat machines with a bit more of like make sure what's getting processed. I'm not trying to treat them like kids by any means, but just make sure that whatever you're feeding into it is going to get parroted back out at you. So maybe do some kind of checking around that.
Yeah, just maybe not let it out in the wild quite yet.
Yep.
Where do you see the future going for this technology? You know, what excites you most about what it can do?
Honestly, for me, I'm most excited in putting machine learning in more people's hands. So that's why I would build machine learning models a lot, but I really do use the services, and they can be accessed by people who have no machine learning background and just get up and running. And I think I'm really looking forward to seeing the next kind of generations of applications that just have machine learning embedded automatically and really leverage these services. There's going to be more machine learning models made available that are pre-trained that people can just grab and run with. I think will be so interesting to see where that goes.
That sounds fantastic. I mean, at the end of the day, I suppose, you know, with the topic of your talk, do you ever envisage a world where there's still going to be services that you will always have to buy or you will always have to build?
I think so. I think because there will just be niche problems, and it might be a case of you use pre-trained models more and more and more, because you'd be surprised how much overlap there is between maybe text and maybe images and the core functionality of the models. But I think we'll always need a bit of skill to actually be able to turn it into something.
Yeah.
And secondly, I think maybe that will change, but then we'll need developers for something else and something else and something else.
Yeah.
As the kind of foundation grows and what's kind of the basis there, we'll always come up with something cool that we need to do on top of it and something interesting. I don't think we're going to, for a while, have machines that can write programming for us. So I think we're always going to come up with a kind of next thing, unless we have machines that are sentient, but that's a whole different issue.
Yeah, well, at least we're not out of a job yet.
Yeah, exactly.
And speaking of the future, if someone were to get started, where would they go? Where would they read? And
if they are getting started from scratch, I would recommend either there's a hands-on machine learning textbook. If you Google that, hands-on machine learning with TensorFlow, it is a great from start taking you through those. If you want a free course, Google do a machine learning crash course that's available. It's kind of gets into neural networks a good bit, but it'll give you the written ones give you a good overview. And if you're a programmer looking to get started, I would really recommend checking out Fast AI. Because it's one of those resources that was just like, why did I not look at this sooner? It just gets you up and running really quick. You get something working straight away, which whenever you're doing machine learning, sometimes the most soul-destroying thing can be just a model that doesn't work so much of the time. So I'd recommend checking out those resources.
Oh, that's fantastic. Those are some really good tips. And then another question here, how do you do automated testing on these models when they're learning? So that goes back to that piece about, you know, not letting it out in the wild, I suppose.
So if you're doing automated testing, whenever you're training it, you sort of have the test in there that essentially just checks how accurate it's been. And that'll be done whenever you'll sort of keep some of the data back and you'll test it through that, and you can do that on the deployed scripts whenever you're doing that. Whenever you're monitoring, whenever you've got it deployed and it's in the wild, you essentially will need to keep back some of the results that it's giving, and you'll need to have a human or somebody like that to actually check those results. Maybe you just fact check them against previous examples that you know were correct and so on. So basically you just want to have some kind of monitoring service there.
That's fantastic. And then I suppose a little bit about, you know, what you're working on at the moment as well. You know, anything fun coming up?
Well, I currently have chatbots in the brain, so was doing a project for a hospital there and creating a chatbot for them and getting just essentially question and answers. They were getting the same questions over and over and over again and just getting a kind of quick solution up and running for them. I've written one blog on Medium about how to deploy the chatbot because Azure have great tutorials out there, and a lot of the examples I showed today are the tutorials. but when there's a couple of pitfalls you can fall into. So essentially, follow this, you'll get up and running, and I'm planning to release one soon about unit testing those chatbots, as this is done through Azure bot framework, and it's the great example for machine learning. Every time I look at the framework and then a year later look away and come back totally different. Unit testing is one of those examples, but it's honestly kind of relevant for machine learning. They keep changing, they keep getting better and better, and it's all great, but it does mean you do have to keep relearning how to use those. So I'll be covering off how to test those, which is great new functionality.
Fantastic. I suppose chatbots sometimes end up with a bad reputation.
Yes.
So how do you counteract that? How do you make it human?
See, that's the interesting bit of whenever it comes to having a chatbot, unless you're willing to pour so much time, so much effort into it, it isn't going to be just as human as you'd like. So it makes sense to have something instead that kind of works. So sort of if you simplify the process a good bit and leverage those machine learning services, so for example, with questions, there's something called Q&A Maker that essentially allows the matched up of the questions. They think of everything that it could want, and if not, then they point it out a human. They give contact here, provide this information. So essentially, it's not so much making it human, but to stop it being frustrating, limit what it can do to make it really, really good at that, and build up from there. Pour the time and effort into making sure it's working correctly.
That sounds perfect. Hopefully that will reduce some of the frustrations.
I know. It's just, can it work? Can it give me the answer, please?
I suppose there's nothing wrong with ambition, but sometimes they get ahead of themselves, you know. And is there anything in particular that you've been really excited over that's come out in recent year, you know, any developments?
It was, trying to think, I think it was OpenAI. Exciting might be the wrong word, but the free text that they're able to write that they then refused to release because they said it could be used for bad so easily. And then equally deep fakes, like those things are getting crazy, like the amount of things that are out there. But so it's sort of exciting to see that technology is there and working, and I'm also very excited to see what are the ways that we're going to be able to combat it and to make sure that we are getting the truth for journalism and the truth for deepfakes out there.
Absolutely. Like with a lot of tech, you've got issues surrounding morality of how tech is used. So that would be a very good, interesting area to look at, and especially mentioned deepfakes.
I know it's something that I'm just really. I think at least part of the reason why I'm so drawn to AI is has so much potential for good in so many healthcare, like how many things to do with COVID-19 have we seen that have been like AI analytics related, but also has the potential to do kind of so much like bad nearly, but without any intention behind it, or even then what happens when there is a malicious intent. And I can just see this becoming more and more relevant. It's one of the reasons I'm so interested in AI.
No, absolutely. Well, that is absolutely fantastic. So, I mean, that's been really good chat, and really enjoyed
definitely.
that.
It's been great having the questions. Absolutely. Thanks so much for having. This has been really, really good today.
Yeah,
really enjoyed it.
Thank you. It's definitely something different.
Yes. No, it is. It's class.
Hopefully, I think you mentioned you got to see some of the conference as well.
Yes, no, I did. I really enjoyed some of the talks, the Becoming a Senior, and then Phil's talk. I caught the majority of it before I had to get in the car and drive here, so I'll have to check it out on YouTube after.
No, absolutely.
But and Lauren Taylor's talk earlier today, that was hilarious. Whenever she started playing Smash Mouth at the end, I just giggled. It was brilliant.
I know, obviously, we got a little sneak peek of her talk, so we were just like, that's going to be fantastic.
That is one of those days that you wish you were in the room with everyone to just see, just stare at the audience and see how they're going to react.
Oh, absolutely, because then you also have, I think, a couple of other music-related ones, I think Daniel and Neil's as well, so it seems to be more music-centric today than we originally intended.
Perfect.
But yes. Thank you for coming in, having a chat,
so much.
and for your talk as well. It's really good.
Brilliant. Enjoyed it so much. Thanks.
Absolutely. So, folks, we've got onto our penultimate talks. We have coming up UI testing with Cypress with Stuart Cave. We also have gone are the days of exact matches, specifically SQL joins. That's Bina Sisupal, apologies, and Ramaya Mohankuma. So those are coming up next on track 1 and track 2. Further to today, we also have, of course, our competition winner. We'll be doing the announcements at the end of the day after 5 o'clock. But for the meantime, we shall move on to tracks 1 and 2, onto the talks by Stuart, Minu and Ramya.
Hello everybody, welcome to my presentation, Web UI Testing with Cypress. Thank you all for taking the time to join me, and hopefully you'll find this interesting and potentially even useful in your test automation efforts in the future. This is something that's very important to us in ESO, our mission, to make a difference by improving community health and safety through the power of data. A little brief introduction to me. I'm Stuart Cave, and that's my mugshot up in the top right. I'm a senior software development engineer in test, otherwise known as an SDET, currently working at ESO. After dabbling in software testing during my placement year in the Northern Bank, now known as the Danske Bank, I've since spent the last 14 years in this field, holding a variety of different roles, such as automation engineer, performance engineer, test lead, test manager, test architect. Throughout my career, I've seen a fair amount of evolution in the test automation tool space, starting out with a good old WinRunner, and moving on to QTP, UFT, Selenium RC, Selenium WebDriver. So with 9 years experience in Selenium, you might be asking, why would I want to change that if it's not broken? Well, what if it is broken? What if there's something that it doesn't do? What if there's something out there that does it faster, more reliably, and makes test automation a better all-round experience for the engineers? So enter Cypress. What exactly is it? They claim it's an all-in-one testing framework, meaning that you don't need to set up and install a raft of different tools and technologies just to get it up and running. As you can see on the left, before Cypress, typically you would have to pick and manage various bits and pieces and pull them all together and manage it all separately, whereas with Cypress it all comes bundled together, making the installation process simple. Most importantly, what differentiates it and the other end-to-end testing tools out there is that it's not built on and does not depend on Selenium. So you can test anything in your browser. The test runner itself is completely open source and free. There is a web-based subscription cloud dashboard model, which obviously you pay for. You can execute your tests on that, and they will store and host the results for you. But Cypress itself actually runs inside of your web application, which is very different to how your traditional testing tools work, and we'll talk about a little bit more about that in a minute. It is JavaScript only, so there are no client bindings for other languages, such as Selenium. So how does it work? Tests are written in JavaScript only, or anything that can transpile into JavaScript, like TypeScript, for example. You can use your favorite IDE, like Atom, Visual Studio Code, etc. It uses pretty simple commands like type, click, select, clear, set, and so on. They're all pretty self-explanatory, and there's a lot of good supporting documentation about them out there. It bundles with jQuery, so you can use familiar jQuery-like selectors. It also exposes native DOM traversal methods for cool stuff like .children, .first, .parent, etc. All very handy when it comes to trying to find that unique browser element that you're trying to interact with. It uses Mocha for your Mocha framework for the test execution, so your describe and your it blocks, and then it uses Chai for assertions, so checking things are visible, checking it has a certain value, it's enabled, disabled, etc. Which you can see there, it can be used in BDD or TDD type syntax. There's a friendly UI for test execution, whereby you can actually see the test running in the browser as well as the steps as they execute, whether they pass and fail in real time. You can also run it in a headless mode, which is useful for your CI builds. Cypress uses a chained command mechanism, whereby the promise of each command returns the subject onto the next command. As you can see here in the example, Cypress will select a jQuery object that has an ID of login button, and then it will pass that subject to the click command, which will then in turn click it. So these are what Cypress say differentiates it from other tools out there. As you go, it'll automatically snapshot your application state at each test step, which is really useful for debugging. You can go back and see the DOM state before and after each action. So before you click a button, the state, after you click it, what state it is, as well as inbuilt screenshots, which also are handy. The inbuilt waiting for commands and assertions up until a configurable and overridable timeout value. So there's no more waiting for X to happen, waiting until Y. Because Cypress runs in the same loop as your application, it will listen to the native browser events for you automatically. And due to this, Cypress is also extremely fast. There are no wire calls between your test code and the browser itself. So think of polling for something in Selenium. The code will have to communicate back and forward, waiting for something to happen many times. That's further exacerbated with remote executions on the likes of Selenium Grid. You can also make headless requests to set up application state. For example, log in and then navigate directly to a page and then open that page itself and maintain all that session that you set up in the login process. So all your session variables and cookies are set as if you had logged in normally. Stubbing and mocking, you can intercept HTTP calls and stub them, so you don't need to rely on third-party services to be available, or maybe they're a paid-for model, so you don't want to hit them too many times. You can also manipulate the payload that it returns to your browser. So, for example, I could set the response of something to be true, which would show a field. I can then test that, and then I could then also set it false and test it without ever having to hit the server or change any data. UI developers are also using Cypress for testing, which I always think anything that gets the developers thinking about testing themselves is always a good thing. So these are just some things that I've found to be pretty cool in my time so far using Cypress. The selector playground, which is featured in the screenshot there, lets you learn and test your selectors in the test runner itself. So you can click on an HTML element and it will highlight it and show you a valid selector that would enable you to interact with that. You can also paste in your selectors that you've maybe developed in Google Chrome or Firefox to test them, and it will highlight them in the browser and show you how many attributes or how many elements match that. As I mentioned on the previous slide, the headless requests are very useful. So in my application, I have a login function that will set all my state, and then I can just visit any page that's behind the authentication that I need. I make a post request to the login form with the credentials, and then check response values, cookies, headers, etc. And then I can just open up any page that I need to. It's really fast to compare to going to the browser, submitting a form, and waiting for an HTML page to load up. There's no need to wait for elements to be visible or check that a page is loaded, or worse still, the dreaded thread sleeps that I'm sure you've seen plagued across many automation frameworks in your time. Cypress automatically waits for the browser events to complete for you. It is actively being developed. There's a nice open source community out there with people suggesting new features, voting on features, as well as a product roadmap. There are new versions released all the time with bug fixes and various new feature enhancements. There's tons of third-party extensions and plugins for all sorts of things out there, integrations, reporting frameworks, etc., which is really nice to see, and it shows that it is actively being used by the testing community. There's a built-in retry failing tests mechanism if it's required, which is nice. You can set a global retry value to automatically rerun any of your failed tests, or specifically certain tests. API testing, you can combine your API tests if you wish. As I mentioned before, you can make HTTP requests, you can supply the bodies, you can assert on responses, so it might be useful to have all your test automation in a single framework rather than having multiple different frameworks and technologies. There are loads of great examples and recipes, as Cypress call it, on their website to show off different functionality, different plugins, different features, and how you might go about using those. But as with all good things, there are some limitations. Cypress runs inside the browser, so it will only ever support JavaScript, and they're very clear about that on their website, that no other languages will ever be supported. Like some other automation tools, they struggle with multiple browser tabs or multiple browser sessions concurrently. But instead they say that you should check that the link attribute would be as you expect, rather than clicking the link brings you to the place that you would expect it to bring you, which does kind of make sense. Why test the browser functionality? Brings you to a page. Why not check that your application has the correct link? Each test is bound to a single origin, so I cannot have a test that visits google.com and then goes to bing.com, but I can have separate tests that will visit those different origins. I guess the other thing that comes with just how widely used the tool is. When you go to search for a particular error or issue that you've maybe come across, you won't find as many posts on Stack Overflow or the likes that you would for Selenium. But there are certainly posts out there for some of the common problems that you might encounter. So the verdict, I've been using Cypress for around a year now, and I've been really, really impressed just with how stable and robust it is, both in terms of the test runner and also the test results. I can't remember the last time I had a failed test that didn't actually turn out to be a problem with the application or my test script or my test data. It means there are no tests that sometimes pass and sometimes fail with no clear reason. It's really helping to build confidence in the test automation that we have in place, and it means that failures are properly taken seriously and properly investigated. I'm not saying go and bin your mature Selenium-based test automation framework in favour of Cypress, or well, maybe I am. But if you are looking to get a new test, get started into test automation as a beginner or a novice, or you're looking to start testing a new web application, why not give a quick proof of concept with Cypress? I didn't want to pull down all the examples, videos, tutorials, and things that Cypress have on their website, so I suggest if you are interested, go visit their site. It's completely possible to get up and running with Cypress in literally a matter of minutes. Thank you for the time, and hopefully that was useful for you all.
All right, welcome back. Thanks for that last one, and that nice short and sweet one. Right, May interviewed me, so guess what we're going to do now?
Oh no. Mark gets
May.
his own back.
So tell me, what are you up to these days? What are you expanding up to?
Oh, expand. Well, yes, well, the company itself, we develop software, and the purpose of software is to manage and develop business cases, and it also aids in the tracking of the programs that come out of these business cases. So a lot of it's focused on sort of government sector and so on, you know, how public money is being spent basically, and how that has impacted you know, the local economy or whichever area that it's supposed to impact. So it's quite fun work, actually, believe it or not. Lots of challenges, and the whole idea is just to make life easier and make that process of getting that money into down to the ground, down to the programs that are going to help people faster.
Right. So essentially, you know, public sector bodies have money that they want to spend on improving things, and you're trying to tell them these are the things that you could best spend your money on.
Yeah, I'm giving them a cheaper and faster way of doing it.
Yeah, and then tell them how they can then do that.
Yeah, exactly. So, you know, we've worked with quite a few councils now, and we're also involved in quite a few the schemes around Belfast. You know, we work quite a bit with the Smart Cities lot as well in Belfast. So it's lots of fun stuff coming down the line, especially with the Belfast Region City deal coming up too. So that's ramping up.
Is there anything you're particularly proud of that you've managed to contribute to? That you can tell us about?
That I can tell us. Well, I quite enjoyed the work that we put in for COVID Connect NIDevConf. So whenever everybody went into lockdown, and obviously you had businesses and organisations and charities all kind of going, oh no, we need support with IT. You know, our staff need to work from home. How do we get that? Or we need a PPE. And then you've got other companies who are the opposite, who are like, oh, we could provide PPE, we can do this, we can do that, we can give pro bono or cheaper services to help you manage your IT. So we set up, working in conjunction with Belfast City Council, we set up COVID Connect NI, and just companies sort of just signed up, said what they can offer or what they're looking for, and then it's effectively a matchmaking system.
Yeah, so is this sort of is this a data problem essentially, or?
Yeah, it's the fact that a lot of this is disparate. You know, and people didn't really know where to go. There wasn't really a centralized source that people can just go to and get all the information they needed about what government support is out there, what's in their local area, what, you know, things like that. So that was part of trying to collate a lot of that together, so it just made life easier for people who wanted to offer help and also people who needed help.
Yeah, so one side has got lots of money and the other side wants lots of money, and you're helping to actually bring them together.
Something like that.
Oh,
So,
right.
but no, it's just trying to help bring everything together, make life a lot easier, and actually get the money where, help to get the money where it is.
I imagine it feels good when you're working with sort of places that need the money. It's not like it's not one of these things where you're just working to make rich people richer.
That's it. It's there's a net benefit to society. At the end of the day, we might work with businesses, we might work with business development teams and so on, but it's all focused about giving a net gain to society.
Yeah, that's one thing. It's nice to work with companies that are actually trying to do good things rather than just grease the wheels.
You can't affect change unless you're inside the system, I suppose, in some ways.
Yeah, break the system from within. Right. Okay. Anyway, I think we are approximately up to the next speakers now. So
yes, brilliant.
Let me see if I can do it from memory again. Right.
I don't know how this man does it.
I'm not going to remember the name of the person on track 2. Track 2, Gavin Fenton. And he's going to be doing a talk on continuous application security. And on track 1, we have John Glass from ESO, who are a company who also work in a company that does good things. And he's going to be talking about something that sounds quite fascinating, cache-driven testing.
So it'll be fun.
Over to you, John.
Great, thanks very much. So my name's John Glass. I work at ESO as a development manager. I still enjoy coding. I still make a lot of time to code as part of my job. And I guess the theme for today is around some work that we've been doing within projects that I'm involved with over the last year or so. And it's kind of a theme for me as well. I think probably the biggest light bulb moment for me in my time coding was when I really understood what test-driven development meant. Building out tests first, I guess, and then fixing them. And I think behavior-driven development is a kind of evolution of that, where we kind of extend that to say, what am I testing? Am I going to test something that is a kind of internal behavior of an application, or am I going to test something that's actually an externally observable behavior of an application? BDD is really, really powerful. I love it, but it can introduce some complexity around how to test, because if you're testing kind of larger swathes of your application stack, it can be quite hard to figure out a good way to do the testing. So I guess the theme of this talk is kind of zooming out from what we do day to day to some of the things that will facilitate what we do day to day. And one of the things that I enjoy about my job at the moment is kind of zooming out again from that and thinking about kind of how it supports the mission of the company in terms of what we do. So I guess in a lot of things that are more physical and more visible, in order to build a machine, you have to build another machine first. Wind turbines, I kind of love wind turbines. Some people like them, some people don't. But I love this guy in the nacelle here. Like, his job is to do these bolts up to hold the blades onto the nacelle. The thing's going to spin around, generate power. And there are probably times that he forgets that he's 120 meters up in the air. And that the thing he's bolting on is hanging from a crane, his job is a small thing, but it's enabled by a whole bunch of things that are around him and helping him to do that. And somebody had to build those. As software engineers, we're responsible for building those things as well as for using them. So I guess this is kind of an observation of mine around continuous integration. And some of the problems that it can give us. So what we'd like to do is we'd like to test the whole application on every development branch. So we know before we merge that everything works. Test runs should be fast, they should have high sensitivity, and they should have high specificity. That means they should have high false positive rate, or very low false positive rates, and they should have very low false negative rates. If the build goes green, we know that there's a problem. And probably more perniciously, I suppose, if the build goes red, we know that there's a problem. Flaky tests are a huge problem with sort of end-to-end testing, where you go, oh yeah, that one always fails, just merge it. Oops, what have I done there? Yeah, so hitting external services is problematic. If I need external resources, then I have to stand them up in the environment. And if I want to run branch builds, I want to run builds in parallel, I need to really have minimal external dependencies. And even with kind of containerization, standing up a whole environment for every build, it can be complex, it can be slow, it can be expensive just in terms of compute time. So typically there's a bit of a compromise. What you run in kind of CI and what you run after you merge. And then when we find defects after merges, we kind of have to ask, well, how could we engineer an earlier warning? So I guess to that topic of selectivity and specificity of tests, people that have written tests, hopefully a lot of you, will know that there are different ways to do this. So unit testing is kind of fast and detailed. I can test an individual service, or I can test a couple of services or a few services, but it's not typically behavior driven. And so it's pretty brittle when we come to refactor. If I change internal interface boundaries that unit tests rely on, I typically have to rewrite all of my tests. And that's kind of a shame because tests represent knowledge that maybe passes on, bugs that somebody found while they were writing something are not necessarily easy to find again later. Mocking is kind of typically the answer where you've got external services and you don't want to be dependent on them. So if we create mocks at kind of interface boundaries, then we can end-to-end test the application without the external dependencies. But mocks themselves are brittle. Brittleness is a theme, but toughness is the opposite of brittleness. And the definition of toughness is kind of quite informative. It's the ability of a material to deform under load, under stress, without breaking. So it's basically like how much damage can your test take before they fall apart. And then in terms of brittleness, breaking, it says here, breaking is often accompanied by a snapping sound. Now, anybody that's ever maintained a kind of complex set of mocks has probably heard that snapping sound as they're kind of carefully maintained Ming vars of mocks just falls over because the particular path or the particular order of things is not being respected by a change to the internal code. So toughness is something we want to achieve. End-to-end testing kind of does that, but it has the drawbacks that we talked about, which is that it can be hard to set up, can be slow to run, and it can be unreliable. If I'm doing things like Selenium browser automation testing, I can have quite a high kind of false negative rate. So cache-driven is a kind of hybrid approach. We work in two different modes. The first mode is in local development, and I typically I call it harvesting. So harvesting is the idea that I'm using a local mode where I've got all of these external services to harvest and kind of automatically create the things that I would otherwise have to manually lay out in mocks in my kind of mocking framework. And in that kind of harvest equals true mode, I'm connected to the databases. I have a read-through cache, and that cache is serialized into my source code. And the mock is therefore kind of self-generating and self-healing. So if I run my tests, if I've changed something, even as simple as a new line in a SQL query, or changing the name of a parameter or something, that can break a mock that I've carefully set up. But actually, what I would see in the read-through cache is that query would just change. And then when I look at the change in my source code, I'd see, well, my cache has changed slightly, but actually that hasn't affected the behavior. On my CI pipelines, I set my harvest to false. So harvest false means I'm going to have no external dependencies. It's not a read-through cache anymore, it's a read-only cache, and the cache is stored in the source code. So the mock service mimics the external dependency precisely, provided the code does all the things that it did when it was harvesting. And so those tests can run fine on my CI pipeline, and within reason they're pretty tough with respect to internal changes in code. So I guess I was just going to say, yeah, this is the example I've shown here is for a database, but we do the same thing with APIs, with file stores, any external dependency you can think of. Actually, database is probably the hardest one. APIs, a JSON API is trivially serializable, obviously in terms of requests and responses. So I wanted to show you a demo. I wanted to show you something a little bit more interesting, I suppose, than just a database and an API. So this is a tool that, that we use internally. We've picked up a couple of applications by acquisition. And those applications have a lot of legacy code in them, and one of the things that we've picked up is a lot of VB script code. It's kind of expensive, time-consuming, and error-prone to rewrite that and to port it into a new language. So we've written a tool to help us do that. We call it ASP-cop because it started out life as a static analyzer for VB script. And then once we got good at kind of parsing VB script, we kind of expanded it and found that, you know, this transpilation idea was actually workable. And it kind of has two pieces. So the one piece is the transpiler, which takes ASP code and it turns it into C# code. And the second piece is the runtime, which you can see the kind of light box on the right-hand side there, which the C# code kind of talks to. It emulates the runtime that the ASP code was expecting, and it interfaces out to the .NET runtime. So you know, there's quite a lot going on in there, but the thing that we want to validate, the kind of invariant, if you like, here, is that this legacy code, if I convert it to C#, it should serve exactly the same page as it did before the conversion. So in that example there, I've got my browser client. It's hitting the classic ASP site, the legacy site, and it's going to serve an HTML file back to me. What I want to do is I want to run through that transpilation process, spin that transpile code up in the runtime, and I want it to give me exactly the same HTML file. So let's see how we can do that. So what I've got here is a set of test cases which are called the transpiler test cases. And there's two important tests here that I want to show you. The first one says test cases converted should convert to C# correctly. So my test cases should transpile. And the second test case says transpile pages should serve same content as IIS. So to give an example of this, here is a classic ASP file. Some of you may be unfortunate enough to be familiar with this and understand it. Many of you will be lucky enough not to. It's quite familiar if you know ASP.NET. It's the forerunner of ASP.NET. So it kind of has a good history behind it, but it's not really great for running production applications today. So this page, I could put this on a site, and I could get the HTML for that page by just serving it off the site. And indeed, that's kind of what I've done here. So what we store in our test project is the ASP file, the C# file which was generated by the transpiler, and you know, if you look here at this, you can see I've got my HTML body. It's kind of doing the same thing as the ASP file here, slightly less elegantly, but I'm basically just writing HTML response of this kind of A, B, C, D, X. The tool has done that, it's generated that automatically. The other thing that I need is my expectation. So in terms of my expectation in the test, it's the HTML document. So I've got this in here, and what I can do is I can run my tests here, and these tests run, once they finish building, they run pretty quickly. So there we go, that's done. That's all my test cases run, because there's no external dependencies, so it's super, super fast. What I've got, though, is I've got a problem. So I found a bug, and I'm going to take you through fixing it. So what I brought in here is a new file. Which should be popping up here. Let's check that I've got this. Yeah, there it is. Cool. Right. So this is another ASP file, and this demonstrates a bug that we found a little while ago, and it's in the dateAdd function. So dateAdd, as you probably expect, is going to add, in this case, 7 hours to my test date, my source date. I'm starting with 8:29, so I'm expecting like 3:29 p.m., I guess, as my output. But what I've also discovered is that if I add a fractional number of hours, it's not going to add that extra rounded number. It's just going to add 7. So the behavior of this function in classic ASP in the original code, in the original runtime, is that it truncates this 7.8 down to a 7, and we found that actually our code doesn't do that. So our runtime doesn't do that. So I'm going to run the test and just walk you through what this does. So in the first case here, the first thing it's going to do is it's going to try and transpile it. And what this one will say is, well, I expected nothing because that C# file wasn't there a second ago, but I got 53 lines of C# code. That's great. So the C# is now here. It's generated. I will run the test again, and this time that first one should succeed. So I've got this C# file. That's going to get checked in to source control, and that's my kind of reference between the two. The next stage is then my should serve same as IS. Now this one's failing. It's saying expected 0 string length, but was an HTML file. So the reason it's saying 0 string length is because I don't have the HTML file. The HTML file doesn't exist. I don't have any means of kind of knowing directly what the output should be. So I could handwrite it, but actually what I can do is I can use this kind of harvesting mode. I'm going to go up to the top of my test class here. I'm going to change my harvest flag to true. Now what's going to happen is, based on this harvest file, this test does one of two things. So if harvest is false, it's just going to load the HTML file from the source code. That's the thing that's checked in, no external dependencies, and that's what you saw before when all those tests were running and going green. If harvest is true, then I'm going to hit an internal IIS server that I've set up. So I've just configured port 7979 to map to this folder that has all of my test files in. So if I hit slash what is mine, date add fractional.asp, then I'm going to get back from IIS my reference. It's going to tell me this is what I'm serving to you, and therefore this is what you should be serving from your emulator. So if I run this now, I will get a different result from the test, because in this case the new file will appear. So the new file has appeared. That's the HTML. Again, I'm going to check this into source control. This is the expectation, and you can see here that 8:29 has gone to 3:29 p.m. in both cases. So this is what ASP is doing, but you can also see my test has failed. So the reason it's failed is because the expectation is 3:29. That's what classic ASP has given me. But the actual is I've actually added like 7.8 hours to my time, which is wrong. So let's go back in here. Let's figure out what went wrong. So my ASP.dateAdd has failed here to do the right thing. And the reason it's failed is because when I look at the code here, I can see, well, actually, I've kind of made a mistake here. I've truncated the number for years and quarters and months. But what I should have done is truncated it for all of these values. So I'm going to do this in just a slightly quicker way here. If I just extract that one, and I call this whole number, and if I bracket cast to int, I can now remove these redundant bracket casts. So what I've got here now is every case where I do this addition, I'm going to truncate the value that was passed in, and I'm going to add a whole number of years, weeks, hours, seconds, whatever it is that I need to add. So I save this now, and run these tests again. It doesn't need to re-transpile because the source code is the same. I've just changed the runtime, so the runtime is now fixed. And the runtime is now giving me green. I'm passing because both my transpiled file and my original file are giving me the correct answer. And then just to kind of show you what's happening in source code here, I'll go through these in order. Oh, there's one last thing I have to do actually. This is a good point. So when I run these tests, I've still got one that's failing. And the one that's failing is, again, just part of the pattern here, having a test that just says harvest should be false when checked in. So I want to make sure that I set that harvest flag to false, because otherwise I'm going to get weird behavior on my build server. It's going to be trying to hit port 7979. It's going to be really slow. You know, it's not good. So just to make sure that I'm fully green here, I can now close this, set this back to false. That's not going to build. Set this back to false, run it again, and this time all of my tests should go green. And because Harvest is false now, that means that I don't have any external dependency on my IIS server being present. So I'm going to go back into source tree here. The only changes I've got now are my ASP file, I just changed that. So that's the thing I'm adding, is the ASP file that demonstrates the bug. This ASP.cs was generated. It's not strictly necessary, but it's useful because it means that when I'm troubleshooting issues, I can look at the generated C# file, and I can actually see kind of where the problem may be originated from. And then this is the generated HTML, which tells me what my expectation for the test is. And I'm going to check those in. And finally, of course, the fix. So if I commit all of those, I've done a kind of TDD approach there of sort of finding the bug, proving that the bug exists, creating a test that goes red. I've then fixed the bug, and I'm committing the fix in here, and that's my resolution. So I guess kind of zooming back out again here, this is kind of, I'm the guy putting the bolts into the hub to put the blades onto the fan. I'm doing quite a small job here. But I've made the job easy, and I've made the job reliable, and I've made it behavior driven, and I've made it fast to run across CI, across many branches. It's very reliable, it's got very high specificity and sensitivity because it's all in memory. There are loads of really good things going on here, but they've happened because we've invested time in building a test framework that has then helped to make everyone in the team more productive. And I guess that's kind of what I wanted to share with you. Thanks very much.
Okay, thank you very much, John. And that was the last talk of the day. And I'm pleased to report we've just checked the numbers, and we are bigger than we were in last year. So we've had, well, yes, in history, but yes. We've had more people than we could actually fit into Riddle Hall, which is
twice over, I think.
Yes.
Yeah. If I remember our figures last year, we had about 200 on site.
A little more, I think. But yeah.
So 2 to 250. But this year we've had well over 400 people attend. So wow, thank you. We've had 500 registrations. So no doubt we'll be seeing people tomorrow as well. Maybe late today.
Yeah.
Human-related technical difficulties. Would help if I remember to switch my mic on. But yes, so I was just saying, I'm actually gobsmacked, just the figures, you know.
Thanks so much, everyone, for taking the time out of your day to come and watch our little thing.
Yeah, a ragtag bunch of people who should know what to do with tech, but somehow still suffer from technical difficulties. But no, big thank you to all of our speakers, and just, everybody's been involved today. He came in, talked, pre-recorded, sent in their slides to Mark on time.
Yes, everybody did it on time.
Woo!
I'm amazed. There's hardly any poking of sharp sticks.
And maybe the threat of making you cry. It's like, you don't want to make Mark cry. Helped. But yes.
Should we talk about what's going on tomorrow then? And indeed tonight, I suppose, as well.
Yeah, I suppose it doesn't stop here. Hop in. We've got a session in Hop In. It's just a chilled hangout. Grab a cup of tea, cup of coffee. beer if that's your bag, and just chill, hang out.
Yeah, the great thing about COVID is it doesn't take you very long to get home from work, so
it's great.
You can get the beer open really quickly.
Yeah, I've had the same can of cider just taunting me for the last week, just because of that.
Have you been busy the past week? Have you had any?
Nah, I've just been twiddling my thumbs. You know, it's not like I had a conference to organise. You know, and with another team of what? There's 4 of us, 5 of us.
Yeah. Yes. So yes, tonight we'll be having a bit of like I say, just a chill session, and I think Art might have another little competition.
Yes.
Possibly,
So
which we'll tell us about in due course, I'm sure.
Yeah. No, we'll keep an eye.
Keep an eye on the
Hopin.
Twitter and keep an eye on the Hopin. And
so competition tonight. I think there's more competitions tomorrow.
yes. Well, tomorrow we have another 2 tracks for a full day. And of course, in the afternoon, we'll be handing over the stage after lunch to the Raspberry Jam. So do get tickets for that for your kids, and they can watch along. There'll be talks on learning things, how doing games and that sort of thing, and there'll be workshops and practical stuff going on.
Yeah, I'm looking forward to seeing that actually in action.
Yes.
So, because obviously there have been kits sent out to the first 30 people who requested them.
Thank you again for the sponsors for helping us to buy the kits for the wee ones.
Yep, I'm looking forward to seeing the results as well.
Yeah.
So that'll be really cool to see. So we've got competitions, we've got Raspberry Jam, lots more talks tomorrow as well.
Maybe a couple I think we've got a couple of sponsor interviews and things like that as well.
Yes, a few more sponsor videos, sponsor interviews. A bit more of what we had today, with hopefully fewer technical difficulties.
Yeah, so tune in at 9:30 and see if we can actually get going this time. The most exciting thing you'll see all week.
Yes, absolutely. And I suppose, we said our thanks to the speakers and so on, but we couldn't have done this without the sponsors.
Yeah.
And it's the sponsors that helped us make today and tomorrow what it is.
Yeah.
We couldn't have got the space, the equipment, the service, the platform, anything without the sponsors helping us.
Yeah. If you're on Twitter, go and say thank you to a sponsor.
Hugely. So, just the support we've received this year.
Yeah.
I can't believe it. Honestly,
at the moment, there's a lot of companies that are really cutting back on sponsorship. So the fact that so many stepped up this year, that's been amazing. And it's funded all these lights and cameras and action and and the wonderful people who are actually operating it all as well, because we wouldn't be able to do that.
Nope. I could barely take a selfie.
I can't even take a selfie yet.
Yeah, but go get on Twitter, say hello, thank you to our
and pop into their booths as well. If we've got a few minutes now before the full on party starts. So pop into the booths, see what they've got to offer. Say hello to the ones who are actually in there.
And I'm nearly sure some of them might be hanging around in hubs as well.
Yeah.
But
you could even try some of the networking in the Hopin.
Yeah.
The random networking. Apparently, from people who've tried it, it's actually quite fun. You just go in, it drops you in for a couple of minutes with somebody you may or may not have ever met before, and you can just have a wee chat, say hello, and then you go and do it with somebody else.
That's it. I'm actually looking forward to trying that out at some point myself. So that could be fun. And of course, actually, funny enough, received a message from someone earlier who was in hubs. And they absolutely loved it.
Oh yeah, the VR is great.
It's like they sent a screenshot. It was just Pikachu on the sofa. It's like, this is the best thing ever. And that made me smile. But yes, in terms of our sponsors, as I said, we've had a phenomenal support this year. Prizes have been supported by Fergal Structure and Van Rath. Special shout to BCS, who really looked after us this year as well.
Yeah, not a lot of people realise that BCS is actually a non-profit charitable organisation. A lot of their work is community support. So it's actually their job to come out and help this sort of thing, and it's great that they do, and there is somebody there to do that.
That's it, and they play a very, very vital role, I think, to this community, because they do a lot in the background people just don't see. Absolutely. And then, of course, we've got our silver sponsors, ESO. You heard from one of their speakers earlier.
A couple, actually, they snuck a few in.
Yeah, that's right. They did sneak a few. They're good at doing that. It's not just them. Plenty of companies. It just shows we've really good talent here. Really good talent, that are willing to get involved.
It's a good wee place.
Yeah. So we're sponsors with ESO, Farsight Labs, HHA Exchange, Open Data NI, Quark. I really hope I'm pronouncing that right.
I think they
Quark.
pronounce it.
Sorry, Claire. Shopkeep and SpotX. And then our gold sponsors this year, Allstate, Flexera, GCD, Instill, Rapid7 and Signified. And of course our platinum this year is Sensata. They're first timers, and the fact that they're able to jump up with both feet in has been amazing. So those are the people you thank. Get on Twitter, get into the expo booths, say hello to them, get chatting, so. And I suppose we have some competition winners.
Oh, do we have? Oh, okay.
Yeah, we do. We have some competition winners.
Oh yes,
so,
there's a guy who wins everything, isn't it?
Yes. So, so the lunchtime Tetris winner, drum roll please, is Michael Martin. Woo! So Michael gets a Tetris stackable desk lamp. That's pretty cool.
Why don't I get a Tetris stackable desk lamp?
You need to win a competition.
Okay.
You also need to beat Michael, who has managed both the first and second highest scores, which is around 60,000.
That's just showing off, really, isn't it?
Yeah. So congratulations, Michael. The runner-up was Kyle Harrison, who managed just under 28,000 points.
Oh, he's a carrot.
They're just hoovering up. They're just popping up everywhere. And we got an honourable mention to Ralph McTaggart, who managed to almost miss his own talk because he was too busy playing the game. That's dedication. That's dedication. I like that. So yes, those are our competition winners. And there's more competitions tomorrow. And there's rain.
Yeah, the heavens
wow.
have opened.
That's kind of impressive.
Well, that solves the sun in the eyes, John.
So I'm not sure if many of you clocked, but there is fantastic scenery behind us, with the Harlem Wolf cranes.
Yeah.
Beautiful afternoon sunshine and lots
Cape
of
Hill
rain.
and lots of rain.
Yeah. So that might actually be hail.
Yeah, yes it is. Well, that's auspicious. I think everybody should go and hide in the session, in the social session.
Go to the session, go to hubs, hang out, chill out. And did I miss anything else?
No, I think that's pretty much
Shall we
good.
say good night to everyone for now?
Anybody from behind the camera want to say, got any messages for anybody? No?
Nope. Okay. Well,
no, they all just want to get the day over with.
They do. I can't blame them.
They've got to do it all over again tomorrow. So.
Yeah, absolutely. And so do we? Yes.
Yep.
We do. I have to remember, it's 2 days, not one. That's not normal. But yes, thank you, everyone. Really had a fantastic day.
Some of us will see some of you in the social, and we'll hopefully see you again tomorrow.
Yep.
Okay.
Goodbye. Have a good evening.